Wow, and hello there, everybody. How are you? And welcome to SkyTour live stream for this evening, January 25th, 2022. This is going to be a good night, I hope. We have a very nice, clear sky, and we already have requests coming in. Michael Plagas would like to see some galaxies. Sure, if we can look at some galaxies, we'll find them. And I just want to let everybody know that in addition to myself, of course, as always, Darrell Mason is here. What's up, brother? How you doing?
Hello. Hi, Mark. I'm good. You?
Oh, just fine. It's really good to have you come on tonight. I had put up the post for the stream that was going to go live, and Darrell writes me a message. Am I invited? Okay. Clearly, everybody gets gets something out of this. They have a good time, and
Oh,
yeah, it's really really fun. It's enjoyable. And as we always say, if you're not careful, you might learn something, right? Because there's a lot of cool stuff out there, and we try to stay on the cusp, right on that bleeding edge. So it's nice to see you guys. I want to welcome you all. I saw we have I said hello in chat to a bunch of folks that were here, and I see now Daisy and Zoe are here. Nice to see you, and Donald Kunzer's here. And
Raymond is here.
Raymond Bobel, how you doing, man? The Leo triplet. Yeah, I looked at the Leo triplet the other night. I waited for it. We're going to have to wait a while for the Leo triplet to come up. So I don't know how long we're going to stream, Michael. But the Leo triplet looks beautiful in the scope. So does M81 and M82, which are in the same field. Really, really stunning. I don't think this is going to be a 5-hour stream, which is what we're going to need in order to see that. Because we're going to be focusing on a lot of the pollution in our galaxy, which you can see right here. This is some of the pollution right here. This is, of course, these dark dust strands and locations in our galaxy that are simply, by far, the most incredible locations, because they're the ones that actually formulate the chemistry within them in the deep cold of space in those regions to actually create many of the elements and ices that then get boiled off when a star forms in that region, and those become the raw materials from which planets are made. And I just think that's really the coolest thing. It really is. So that said, I want to welcome you all. Go ahead, Darrell.
Marianne is here too.
No, sir. That's not her. That's a imposter. That's not Marianne. Hi, Marianne. She writes, "Hey, Mark, Darrell, and all my wonderful peeps. Going to be an amazing stream. Remember Peeps? Those really nasty yellow marshmallow things for Easter people got?
Oh yeah.
Yeah. I think all the Peeps ever made were made in like 1940, and they stopped making them. And they just that's candy corn. All the candy corn ever made was done in 1940, and they never made any more. They just keep moving it around. I always felt
We
like
were too poor for Peeps.
What's that?
We were too poor for Peeps.
Yeah, we weren't
We
too
just
poor for
got.
candy
We
corn.
just. Oh no, I loved candy corn when I was a kid. We were too poor for Peeps. We just got poops instead.
Oh, all right.
And I liked candy corn when I was a kid, but I don't like it now. I don't know if it's a difference between sugar and high fructose corn syrup or what, but it's just doesn't do anything for me anymore.
Yeah. I always felt it was like eating a candle. It was like eating a candle.
I could see that, yeah.
If Izabela gets a hold of this, she's going to write, welcome message, discussion of Peeps and candy corn. I guarantee it's going to be hilarious. Well, anyway, this location we're at right now is actually a very interesting location. It's called the Perseus Cloud. And the Perseus Cloud is this right here. You see it right here. Okay, you'll notice that it has this real subtle detail in it. And I've been stacking this for a while. There's 16 of them stacked so far. And I just wanted to get a head start, make sure the telescope's up and running right. We've been concerned with this back-end system going down on us. It's not our fault. It's the manufacturer of the software that connects this telescope computer here in Connecticut with the telescope computer out in the desert 2,500 miles away. And, you know, to Marianne's credit, she will tell us, if I have to go out there in the morning to fix something, you let me know. She's always ready to drive an hour and 40 minutes to get there. I mean, to check it out. So if there's a problem. But so far, that's only happened one time. But I was able to correct it the following morning when we came back online for the maintenance segment. We have the telescope comes up, not the telescope, but the building power. I have set it to come up at around 8 a.m. their time, in Arizona time, and it goes down at 11 a.m. So there's a little maintenance phase in there that I build in so I can get in. Now for me, that's 10 a.m. to 3 hours to 1. And so it used to be 11 to 2, but with the time change. Donald Kunzer says, "This is the someone sneezed on the camera lens nebula." That's kind of funny. He kind of looks at it. I've actually had some weird things on the lenses that sort of resemble that, but I can promise you that's not this. Promise. Yeah, very cool. So anyway, I'm really happy that you guys could be here. I'm going to see if I can make a little bit more detail come out of this nebula that we're looking at right here. And we'll try that right now. Just going to pull our black level down, so make the stars darker and kind of make the cloud a little more visible. That's good too, but I'm going to go one more little notch. There. Let's try that. Yeah, now you can actually see that darker cloud and this lighter part of the cloud much better. That's really interesting.
Darker cloud, that's Barnard 3, isn't it? Another one of Barnard's dark objects?
That's correct.
Yeah.
Yep.
Like
tell everybody about E.E. Barnard. Like, you remember our radio show when you did that?
Yeah, I'll see how much I remember.
No
E.E. Barnard was a astronomer and a pioneer in astrophotography back, 120 years ago, something like that. And
before our time.
Yeah, he worked in black and white, of course, back then, late 1800s, early 1900s, and he shot a catalog of dark objects in the sky, and it's called the Barnard Catalogue. And this is in there, Barnard 3, and things like Barnard 33, which is the Rosette Nebula, and many other well-known objects.
Yep. Yeah, I see you know more than you think you know, Darrell, right? I mean, you always figure that out, you know. I was talking to a museum today about some potential work with them, and they were very science-oriented, heavily science-oriented, and it was nice to be able to talk to people that understand science, you know.
Sure.
Because you're used to having to explain, and when you don't have to, you almost forget and think I'm missing something, you know. But it's all right, because I always went to the side of thinking I want to explain, and I always like doing that. That's why I love you were here. You know, you like to hopefully hear the things that I have to say about these objects and so forth. And it's always different. You know, we always look at some different things. Sometimes we look at the same thing, and you always might wonder, why are we looking at the Pleiades again? Why are we doing this? Why? Well, I'll tell you why. Because we're actually creating a historical record of everything up there in the sky. And this historical record is a valuable commodity in the event that something changes. You know, it was 100 years of observations that allowed us to see the Crab Nebula expanding as it does, a supernova remnant. We've taken pictures of the Crab Nebula, and if something were to change between our very first image and the very last image we took, we should be able to pick that up. And depending on what we're taking pictures of, you know, I always take, many times I'll take pictures of the same thing for the same amount of time so we can compare, all right? And we use a little software that allows us to actually show us one frame, then the other one immediately. And it does this blink thing, and that allows us to see subtle differences. That shows us variable stars, especially if you're taking images at the same height in the sky and the same time of the year, with the same clarity of the sky. Very, very important factors to consider and you can see if there's a brightness change. So, for instance, we shot Betelgeuse when it was very bright. We shot Betelgeuse when it wasn't, and you could clearly see the difference in our imagery. You see bright, not so bright. You know, it was really cool. You know, hi there, Tim F. Thanks for coming. Good to see you, man. But you're late to class, brother. It's all right. So anyway, this is 25 of these stacked, and that's good for now. So I will stop this here. And, well, just so you know, we're getting 3 second or so lag times now with this. And I don't know why we're getting 3 second lag times, but I think it just has to do with load on the system between here and across the United States. So it's okay. All right, so what I'm doing is I'm saving this now. Hey, Ray, thank you. I'm saving this image as a stacked file. You can see that right up here in the green. Okay, and that stack is called FITS, F-I-T-S. That's an astronomical format. And I think that, you know, it's important also to understand that I saved the ping files too. These are images to save this just as you see it. All right, I just did this, but I'll do it again just so you can see. So right there, you see me saving this again exactly as seen, just like you see it in the screen. All right, and so now when you go to our live server, which we have, these images are already on their way up. And you'll see them. In fact, the Pleiades are up there too, because I did a nice little test shot of the Pleiades, which really came out nice. And you can take that one too. And that's up there. So I wanted to do that in order to illustrate for you that all the images that we take are not lost. They're always visible to you. And they're always going to be there. So even when I hit clear, like I just did, and it goes away, it's not gone. It's on the server. All right. And then I get out of the stack, and I usually come back to the camera controls, which is this side right here. And the most important value here in the camera controls section, let me just get rid of this menu I don't need, is this right here. This is the exposure time. And when we're going hunting for things, I say 1 second. All right. And now our screen gets updated every second. Camera takes a 1 second picture and updates. And then I'll stretch it to make it really bright. So now you'll notice that the noise changes every second. See that? See how the background noise is changing? Okay, it's changing and changing every second. So it's a new frame. But now what I can do is I can actually move the telescope. So when I hit the N, the telescope goes up, and you'll see a streak as it moves up a little bit. And this gives us the ability to move around within the frame and see it happening live. I don't have to do 1 second. I could make it real time, you know. But we're looking at faint objects, so you know, I could do it that way. But I want to be able to see the objects move, but I also want to be able to see the objects at all, and that's very important. So right now, so for those that, many of you know what this is already, but this is the telescope control system right up there. This is the telescope actually in the building, live view. This is our view here of the night sky. This right here is our telescope computer we look into. And this one way on the other side, this is our camera control, as I said, okay? So that's this right here. Now, you'll see me also at times, I will take the images if we want to actually maximize them, and I will actually take this and get rid of everything on the screen except the image. So now this is the live image. So when we're taking images with stacks, this is what I'm going to do. And many times I'll actually move myself, not you, I'll move myself over here when I do that. All right.
Izabela's here.
Izabela. Hi, Izabela. As
Hi,
always, Izabela, you did a nice job with our table of contents for the last stream. Folks, show her some love. This lady takes every second of our streams and she translates them to a table of contents that I copy into the description so you can see what we did and just go click on it and go there. The chapters. So I think she's done a nice job. And, you know, if we were getting paid for this, she would be commanding some pay. I can tell you that. You know, she's fantastic. So thank you, Izabela. I mean it. I'm not worthy. You know, Darrell might be, but I'm not worthy.
Oh.
Okay, so the other part of this is the planetarium view that we always bring up. This here is a live view of the telescope's location. You might notice it moves around a little bit, so the telescope is feeding information to this program. This program is saying, yep, I got it, right? And this square is our view, all right? So in the middle of the screen, we have a star called Atik, and the telescope's just a little bit low right now. So if we come back to this, all right, we'll see that Atik is up high, like we saw, and the telescope is a little bit lower than Atik. So we see a one-to-one correlation with what we're seeing in the sky. You know, I know that I kind of make this look easy a little bit, but you know something? This really took a while to figure out. I want to make sure that it was the best experience for people to have on YouTube. I wanted to put it up on their big screen TVs and sit back and watch it like a movie and say, wow, check this out, you know. And it's an interactive movie because you can be part of it, you know. Let's go see. Is this the crystal ball? Oh no, it's IC203. That's a planetary nebula. A faint one. Yeah, I've never been to that one before. Let's keep going. Yeah, see that? Yeah, these are really cool. That's the California Nebula right there. Would you like to see the California Nebula again, guys? I just shot it last night in a private stream, but I'll do it tonight for you again.
Sure.
I think it was really pretty. Okay. So we'll do the California Nebula, and then we'll take a picture. This really shows you what the telescope can do. It really does. So here we go. Hey, John Scott. How you doing? All right. So right now the telescope is heading to a bright star, probably that one. And it's called high precision slewing. And you can see right here it says high precision slewing. What I'm going to do is actually move this up a little bit so you can actually see what it says. Oh, I see what I did. Never mind. I got to move this up. There we go. There we go. Okay. So we're going to Epsilon Persei right now. And then it's auto-centering it. And then it's going to take us to an object that is just dominating the view. And this is the California Nebula, named for obvious reasons. It looks like the state of California. Okay. Now, many people in the past would have been happy seeing this. It wasn't enough. So what we're going to do is we're going to move the telescope a little bit to the west and pull in the other half of this. There we go. Just a little bit more because there's more out there. And we're going to drop south a little bit. Move it up in the field just a tiny bit just to frame it nicely. So we're going corner to corner. That's about good. So now we wait 11 seconds. Why? Because that's how long it takes for our telescope to get a guide star. So one of these faint stars you see here, it might not even be one you can see. It's going to use the guide and keep the telescope focused on a certain point in the sky. Hey there, Alex. I see Trippy Alex Connolly. What's going on? Oh, I'm glad you like the interactivity. That's cool. Yeah, it's great. You know, I'm hoping I'll have some good sponsors for this at some point because it really is unlike other streams out there. You know, I don't think, but you know, it's I don't know. I keep talking. I gotta shut up. All right, let's do a 25-second exposure. So I fill in the 25 up there on the right. See over here, 25 seconds, and you can see this yellow line. This little slope here, you see it's red. Okay, it's got red. It has green and blue in it. That's the data that you're seeing on the screen. It comes in, and this is it. You got a high, bright spot there. But this yellow line is the intersection. That is to say, that's how much data is being taken. The stuff that's under the curve is the data that you're seeing. The stuff to the left, you're not. So if I hit this button here, it means to take it off, and you'll watch it go dark. All right? But if I actually slide that over and I bring it up higher, it starts to intersect the curve more, and we see more data coming in. All right? If I go too far, then it gets too bright. See? And those that had it on their big screen, they're going, ah, supernova. Okay, but we're going to turn that. Yeah.
Your gain's still pretty high. Do you want it left there or turn it down some?
I was going to turn it down, but I wanted to see what the 400 gets us for this, the 450. Okay. So what we're doing now is we're going to stack this and check it out. And what does that mean when we stack? I've explained this before, but I'll explain it again. It takes a picture, and then it takes another picture just like it, and it aligns the pictures together and then stacks them together. And it does that over and over and, oh, look at that, and over again. And it makes the image, it makes your image that you're looking at that much more detailed. It gives you much more data. And right now, I'm going to do a little image processing on this, a quick shot to pull out more detail. There we go. And I'll take the level of the background down just a little bit to make the sky a little bit darker behind the nebula, so we can pick it apart. There we go. Now I'll do what I said I was going to do. I'm going to come back here, and I'm going to maximize this. And boom. Ah, look at that.
It's nice.
It's beautiful. That's the beautiful California Nebula. Now, you don't see this, okay, but I have a screen right here in front of me, and I have a screen right here. This screen over here is my direct view into the observatory. This screen here is the broadcast screen. And I might actually be able to show that to you, actually. Let me do this. Let me turn on my background. And let me try this. It may or may not work. So I'll just show you, though. I want to show you what we're doing. Okay. So right here, that's the view into the observatory. And then this other screen here, that's the broadcast screen. So you see the chat over there. You see the volume levels and so forth. And you see Darrell in here with me and our music selections. So that's what we're looking at there. So that's kind of what the setup is here. And again, doing all of this from that distance away that we are is really kind of, it's always been mind-boggling to me. I've never gotten over it. It's just so cool, you know. But look at this. This is what's called a diffuse nebula. This is hydrogen gas that's being caused to glow. And I believe we talked about this star right here as being the source in this particular case. This star is a hot star. I believe it's carved out a little bit of space around it, which looks like this curve. Okay, it's radially out in the same direction from all directions in this star. I believe this is the star doing it. And what these hot stars do, as I've said many times, they form a cavity around themselves. All right, and do hit the thumbs up. They form a cavity around themselves with their powerful stellar winds, and these stellar winds will also push this gas away and any dust that might be in there. And we know we have dust because you can see there's black dust right here, and there's some interspersed throughout here. So you have dust and you have hydrogen gas. But the star also has copious ultraviolet energy, ultraviolet radiation, and when that strikes the hydrogen atoms that were formerly in a cold, dark cloud, all right, then the electrons are knocked off the atom because they absorb ultraviolet radiation, and then they jump back into the atom as they collide with other things out there, and then they come back in when they lose some energy. And as they come back into the atom, they give off light. Guess what color that light is? I'll give you a clue. It's red. It's the light of hydrogen alpha. All right, that's what we call it. And it's also known as H2. That's H, the letter H, capital H with Roman numeral 2. Okay, that means ionized hydrogen. Okay, singly ionized hydrogen because it can only be ionized one time because it only has one electron. So that's what we're looking at there. It's pretty cool. I'm going to come back in here now and change our gain. The other most important element here is the gain. This is like the sensitivity of the sensor. I've had it on 450 here, 450 for a while, and now I'm going to go down to 350 only because we constantly use that. We don't use it at 400 very much because that's like maximum, and that makes that causes problems.
We talked about E. Barnard earlier. Barnard also discovered the California Nebula
There you go.
in 1888.
Excellent. Yeah, Darrell is a font of knowledge, as you guys have discovered, and I'm really happy that you have chosen to make a home here at Sky Tour Livestream.
Oh, I just looked at Wikipedia.
That's okay. I'm sure other people did.
And the bright star down at the bottom right is illuminating the nebula. It's an 07 star. Its name is Menkib, Menkib, and it is lighting up the nebula, exciting it, I guess is the term.
Yeah, ionizing the hydrogen, yeah.
Yeah, so that the nebula is fluorescing in hydrogen light.
Yeah. Now, that O-star Menkib is actually going to be supernova material in its future. Most O-stars live a few million years, not much longer. And when they exhaust the use of hydrogen, they start taking helium and making it into carbon and nitrogen and oxygen. And they'll go as high as making iron, which is number 26 in the periodic table. Yes, that evil periodic table. Okay. But iron... to try and fuse iron into something else takes more energy than it gives back. That's the turning point. So iron doesn't fuse. Iron stays in the core of the star. All right, that's the last thing they can fuse. And it kind of becomes an irritation actually to the star because it's sort of in the way of a lot of other processes. But what I gotta say about it though is these O stars, like you see right here, these O stars, they end up burning and have shells around their cores of other fusing elements. All right, and to give you an idea, the first fusing element is hydrogen that goes into helium. And when we talk hydrogen into helium, understand we're talking isotopes of hydrogen into isotopes of helium. You know, that is different flavors of the same atom. Okay, atoms that have a different number of neutrons make an isotope. Okay, add a neutron to hydrogen, and you get an isotope of hydrogen called deuterium, which is actually one of the fuels in the fusion process for a star like our sun. So it's kind of cool. When you look at a star like this, there's going to be a point, like at this O star here, there's going to be a point where this star runs out of all the fusible material. And when that happens, the core of the star can no longer support itself. It's pushing out with a radiant energy that's so powerful that it actually balances the force of gravity of millions of potential miles of material trying to crush down in it. Okay? And when it does that, when the radiation stops, gravity wins. And that star begins to collapse. The core begins to collapse. And the core collapse can happen very quickly in stars of that size. And it creates something called a type 2 supernova, type Roman numeral 2 supernova. And that's called a core collapse supernova. And we've seen them happen in galaxies. We've observed them with SkyTour Livestream. Not in the process of happening, but after it's happened. So looking at these stars, when they actually do go supernova, we're in the front row seat, man, for seeing a beautiful light show that has no potential for endangering us. Because the O stars, all of them, are very far from us. They're far enough so that we don't have to worry. Orion's belt, you're looking at O stars. Okay? Betelgeuse is red, and you mentioned Betelgeuse earlier, Michael Klages. And Betelgeuse is actually a red supergiant star. It used to be one of these stars we're looking at right here. It used to be an O star. All right? But as it evolved, it changed because of the fact that it it is a star like that runs out of its energy, it runs out of its fusible items. One of the things I didn't mention to you is it makes all these shells, but during that time, it also bloats up into a gigantic red supergiant. Why red? Because red is cooler, and as this thing bloats up bigger and bigger and bigger and bigger, well, now the outer layers of the star are farther from that really, really hot core. And so the outer layers get cooler. And when you look at a fire, the coolest part of the fire are the orange flames. The hottest part of the fire are what? The blue. And these stars, these O stars, are very blue. But on the outside edge, when they start cooling and get really, really distended atmospheres, very, very, very big, then they look red. And thus we see Betelgeuse, as we do. All right? It doesn't mean much, because it means that, hey, Betelgeuse is going to go supernova someday. And, I think it was Michael that said, boy, that'd be great to see. I totally agree with you. Yeah, I agree with you. It would be wonderful. Now, Darrell says, but it'll be a shame that we won't see Orion the way we used to. But Orion has been changing all throughout our history. When Lucy, Australopithecus afarensis, the precursor to us, Homo sapiens sapiens, okay, when Lucy was wandering around Olduvai Gorge in Africa, if Lucy happened to look up toward Orion, it wouldn't have looked like we see it today. Betelgeuse would have been an O star, would have been a bright blue star in the upper left star of Orion, not the red one we see now. And in the belt of Orion, there would have been maybe one star, maybe two. Okay? Alnitac might not have been there. All right? So these stars, they only live a few million years. And the estimate for some of the Orion belt stars is about 4 million years. So Lucy was just over 4 million years ago. So Orion's belt might not even have existed back then. Might have had one star in it. Okay? So in that time that it took us to go from Lucy to us, modern human, think about it. Orion has changed quite a bit. The universe is changing all around us. We just don't necessarily notice it because we live a very, very tiny slice of that time frame. So anyway, I just didn't mean to launch into a whole lecture there, but it kind of was sparked by this star here, this O star that's clearing this pathway. You can actually see the curvature, and that's probably a somewhat realistic view of the curvature of the radius around the star of its stellar wind pushing things out. When it goes supernova, though, the California Nebula will eventually be a potential birthplace for additional stars. It could be doing that now, but when the shock waves hit, and those shock waves are going to strike and compress a lot of this gas, like a snowplow pushing snow on the road, it compresses it and even starts to melt it, right? Well, instead of melting, what we get is heating out here in space, and that's really going to be incredible to see what happens there. But okay, we stacked 29 of these. I think we'll go to 30 and be done, yes?
I bet we see more O stars tonight.
You think?
I bet.
Name one. You'll be right.
Yeah.
Okay, there's 30, so I'm going to pause this right here. And now we'll save this. So you'll see, again, right up there, the FITS file is now saved. Again, going to our server for all of you to see. And then we're going to save this exactly as you see it here. All right. So that'll be available. If you don't want to play with FITS files, you can just get these beautiful ping files. Download them to whatever you like, because we don't charge. We think that science is for everybody. That's been my philosophy anyway, and it just has to be explained in ways that people can understand. All right, so that's been saved. Away it goes, and we get out of the stack, go back to our camera control, go down to 1 second, and give ourselves a little enhanced finder view. There we go. So that's our live view as we're seeing it now. And to prove it, I can just have to just drop down a little bit. You'll see that it moves. Okay. What are you thinking, Darrell?
I don't know.
You don't? I was thinking we could just drop into on the Northern Trifid Nebula here,
Okay.
because that's right nearby.
Sure.
Here's what we're doing. We're focusing on things high in the sky right now because Orion has to come up and clear this part of the observatory building. Now, this is the eastern side, and this telescope is actually more toward the eastern side. There's a reason for that. The west, south, and north sides of this are just totally open. Not open, but the telescope can see more in those directions because we have Phoenix that's 65 miles to the east of this observatory. And although you don't see it with your eyes, the telescope sees the faint glow of the city of Phoenix from all that distance away. So we want to actually avoid that. So I actually have the east side effectively unusable, and that means that we won't look at things until they come up high enough, and that way be out of the glow of Phoenix. So that's what we're doing there. So now we're moving to the Northern Trifid Nebula. Just look at all those stars. Just think, by just this one little view that we're just seeing in passing, and then it's going to go away, we could be looking at potential civilizations like our own. Isn't that incredible? So, I think it's really cool. If you guys are interested in that kind of thing, there's a book that is a book I wrote. It's called The Populated Universe, and it's a book about our origins. And it basically says that intelligence in the universe is probably a norm, not the exception. Life in the universe actually might be the norm, not the exception. And it's, the smaller one here is about 400 pages long. A lot of artwork in there that I did myself. And it's pretty good. I actually, I was an artist in the past. But, it's also on Amazon. You can get a big color copy with all colored photos. A lot of people like it. So it's, pretty nice. So it's sort of a nice book to have. All soft covers. You can also get a Kindle book too of that, and then you can see everything in full color, any size. Very nice. So now this is the Northern Trifid Nebula. Now, if you're familiar with the Trifid Nebula, we actually see it in the summertime most of the time. Okay, because it is in the summer. Thank you, Raymond. And the Trifid is in the constellation of Sagittarius, and it's called Messier 20. And it's a beautiful nebula that has 3 lobes, and this sort of has similarly looking triple lobes. And that's kind of where this comes from. Hey there, Science Bob. Yes, Trippy, it's available on Amazon. Yeah. And the other thing, too, is if people are interested, I don't know how much you might have seen me before on stuff, but I do an awful lot of TV. I'm on A&E's Proof is Out There. I'm on Discovery Plus, on a Hudson Valley documentary that I was asked to do with a bunch of folks. That was for Travel Channel. And so there's a lot of wonderful work that I do to try and promote science and looking for a sign of extraterrestrial life, something we call technosignatures. Tabitha Boyajian, astronomer, was the woman who found Tabby's star by looking at Kepler data, and Tabby's star was a star that seemed to have a dimming that was unexplained, and that dimming, they thought maybe a swarm of comets or whatever. But the problem was, the dimming was occurring over a period of 100 years. You saw this dimming cycle, and nobody could figure it out. So the star's getting progressively dimmer, and the thing is, what could cause it? Well, one of the things could be a technosignature, meaning it was done by somebody intentionally, another race of beings. Maybe what they're doing is they're putting up a swarm of satellites around their sun to gather all the energy. It's actually a postulated, theoretically possible thing that we can do. It's called a Dyson swarm. Freeman Dyson came up with the concept of the Dyson sphere, completely encasing the star and capturing 100% of its energy. Well, obviously, that doesn't necessarily work because you can't get materials to, be that strong to be able to withstand, the forces imparted to them by a large star like that. But a satellite swarm was far more doable, and so that's what the swarm is about. And they thought maybe it was that. Now they're just saying maybe it's passing dust cloud, because what else? They say it because why not? There is no, we don't know. However, I would very much like to see this one little telescope we just launched. James Webb. I'd love to have the James Webb look at Tabby's star. And that's a favorite object besides TRAPPIST-1 for me. TRAPPIST-1 has 7 planets, 3 of which might be in the habitable zone. So JWST can look and see if there's atmospheres on those habitable planets, and maybe if there's oxygen. Ooh, we might have another world to go see. All right. We're going to do 35 seconds on this. Okay. And we'll take off our little hyper process over here where I really make it bright because we don't want to blow it out. It's really, this is a very sensitive camera. It's probably one of the best cameras you can get for astrophotography. It's a one-shot color camera. It's dedicated for only astrophotography. You can't do anything else with it. And so this is what we're doing. So this progress bar over here tells you how far in the exposure we are. So if you wonder what's going on, look down the lower right. If the bar is moving, we're taking a picture. All right. And we're in a stack. So we're actually live stacking this. So it's there. And I'll come off it. Now watch, this will be the first image and I'll show you something cool. Okay. First of all, let's process it and get it normalized so we can actually see what's going on there. All right, there we go. Now, if we look at this, if we zoom in on this, there's something cool to see. Thank you, Ray. I'm going to zoom into 100%. What's 100% mean? It means this is the full size of the sensor. You see all this mottled color? Okay, watch now. Watch now is about, some of it's going to go away. Ready? Watch carefully. Here it comes. Oh, you see that? A lot of it just went away. And more of it's going to go away with each successive photo. What's happening is, as it stacks, that is noise, color noise. And that noise is being averaged out and taken away little by little. So we're going to have a gorgeous photo. And it won't be any time at all before we can go to 100% and see this like a beautiful image like this without seeing all this noise in here. Now, this is the native size of the sensor. It's 100%, meaning that there's a whole lot more on either side and up and above and below, And so if I was to go back down to auto here and let it fill the screen, all right. Okay, that's great, satellite. Okay, like last night's satellite. That was my own shot. Okay, so there you see. Now we were just looking at this much of it. Okay, but look how much more is available on this sensor. This is a lot of sensor size, but that's a satellite coming through. And because we were taking a 35-second exposure, okay, well, it took 35 seconds at least for this to cross this field of view. And so satellite, mildly visible, crosses. Now you're also going to notice something cool. As time goes on, this satellite trail is going to start to get dimmer and dimmer and dimmer and then go away. That's what stacking also does for you. It actually removes the satellite trails over time because they're not in every shot. But what was here before, the black of space, is behind all these areas that are now just have on one of the frames, one of the stacks, has a satellite trail. So you're going to watch it getting dimmer and dimmer until it's gone. Oh yeah, Science Bob says, haha, get Starlink for internet and have it ruin all photos. Yeah, you're right. But guess what? The other night, we had a back-end issue that was partly due to the satellite internet we use out there now, which is Viasat. and our back-end software that communicates through Viasat to talk computer to computer from Connecticut to Arizona. And we had all kinds of delays, and we had to shut the stream early because it literally was becoming unresponsive. So with Starlink, we're going to have 20 times the strength and power in overnight from the moment we start it. So I'll tolerate a little satellite trail. Notice it's getting dimmer already. With each successive photo, this gets dimmer, and you'll get a point where you don't even see it anymore. I think it's so cool.
I was reading today that the next generation of Wi-Fi is about to come online. It's sort of like the whatchamacallit, the 5 whatever and present cell phone technology.
5G.
Yeah, 5G. Thank you. That they're up to 7G or whatever the equivalent is on Wi-Fi routers, and it will enable multiple gigs per second.
Well, that'd be great, but you want to also do a study to find out what multiple gigs per second does to the human body long term.
Yeah.
Long-term exposure. I mean, airlines are already up in arms about 5G because it's going to start messing with their avionics.
Yep.
That's not good. That is not a good thing.
James Dugan.
James Dugan from down under in Australia. How you doing? Great to see you, James. Let's try something here. All right. We are stacking the Northern Trifid Nebula right now. All right, and then this guy, bring him down a little. Actually, bring him up a bit. There we go. A little more. Okay. Yeah, I think Starlink is great. I've got right now out in the desert. I have at the moment 99.4% uptime in one day. So if we were doing a stream, we might lose it for 4 minutes if it happened at night. 3 or 4 minutes. And then during the day, a couple times, it might lose it for 30 seconds or a minute while more satellites intersected. But I have a feeling that at night we're going to have full coverage based on what I've been seeing. And it's pretty exciting. All right. Now, what you want to look at in this image right here, let me just come back to this for a sec. You notice how this is the sky back here. Okay, this is space. But then this object here has like a cloud around it of fuzzies. These fuzzy stuff, this is actually dark nebula. And this is an area where that star, a star actually, or more than one star, was born in here, like a small stellar nursery, and it ionized the hydrogen. And it made it look like this color. It made it glow red from that process I told you about. It's called ionization and recombination, if you want to know. That's what it's called. But hey there, Jessica S. How are you? And that said, that took a dark, what might have been just a dark expanse of space with some streaks of dark dust in here, and it made it light up. Okay, because it's also got hydrogen gas in here as well. I'm going to change the color. It's a little bit blue. I'm going to see if I can drop that color out. There we go. All right, so this is more like it should be. And let me also bring down our dark level just a tiny bit. There we go. All right, so now we got that. Yeah, now you can actually see some more detail down here. Let's go maxed out on this for a minute. Okay. Anyway, so one more second here. Here we go. All right. So here's what we're looking at. Wow. This is the Northern Trifid. It's really pretty. John Scott, man, thanks for coming out, brother. It's good to see you here. I'm glad you subscribed. Thank you so much. I hope to see you soon. Thanks, man. Take care. Okay. So, if you look down at the screen here, let me come out of this just for a moment so you can see what I'm talking about. We come back, and you'll notice down here, it tells you how many images we stacked. So our stack is 16 images deep right now. And with each of those, remember how we had all those colors and modeling when we closed in up close? Let's go look now and look at the difference. And it'll look night and day, at least it does to me. Okay. All right. Where's the color modeling? You don't see it anymore. And I'll just turn this off for now. Okay. You don't see the color modeling in here anymore. Now you just see the imagery. And it looks soft and subtle. You actually see a lot of the detail in there. You can see that some of these stars actually have secondary glows around them, like this one. All right. There's dark dust that's being made to glow, not glow, but it reflects light. They're called reflection nebula, these blue nebulae. They're called reflection nebulae. But that's not really how they work. But that's what they're called colloquially. And I've never been happy with that name because there is reflected light that will fall onto dark clouds, and it kind of looks brownish. But when it looks blue, it's because the dust particles in the cloud are taking the high-frequency light in the spectrum of the star, which is blue. High frequency is blue. Just like hot colors are blue, high frequency is blue. And the high-frequency light is scattered by these dust grains very, very easily and very, very well. And that's why we see this. And they're blue for the same reason the sky is blue. Okay, the same similar type of scattering process occurs using molecules of our atmosphere that scatter the sun's high-energy blue light. So,
Rayleigh scattering.
that's right. Sir Rayleigh. S-I-R space Rayleigh. R-A-Y-L-E-I-G-H. Rayleigh scattering, there's a lot of different types of scattering. There's Compton scattering, there's Rayleigh scattering, and you know the list goes on. But the point being, the scattering process that we see is one that causes nebulae to be blue when we look at them. You know.
Mark, James Dugan has a question for you.
Mark, I found a site that you put in your location. It gives you the location coordinates of JWST and a few other objects. Sure, James. You can put up a link. Let's check it out. The only problem with the James Webb is now that it's at L2, we would have to take a very long exposure to capture the slightest movement of it. When it was heading away from the Earth toward L2, only as it was crossing, transversing an area as it was moving away from us, would we be able to see any path it left. We tried one night, and even when it was moving at its fastest, we couldn't expose long enough to show it because, we'd have to do it for a long time, Thanks, Science Bob. Yeah, this is beautiful, isn't it? Thank you so much. So that's cool. But I would love to try that. Okay, there it is. James just put that up there. Unistellar optics. Oh, the ephemeris there. Okay, good. Let me see if I can go to that. Moving target ephemeridge. Good. Select target. James Webb. Okay. Let's generate that. Let's see if we can do it. Time and date. Okay. It needs all the data. I didn't realize. Okay, so let's do. What are we doing here? Okay, so that's the month. Good. So. All right. Day is the 25th. I'm just putting. We're still stacking up here, so I'm on another screen checking this out. 25, 2022. All right. Location of the search and address. Oh, okay. I know what you're talking about. All right. I don't have to be. There we go. I just picking the location nearby. And the time that we're going to look for is the local time there. It's not going to matter much. Our local time is
8:29.
You got it right on the screen. Yep. All right. Okay, let's generate now. Okay, we're generating. Actually, you know what? I don't know. I can show you what I'm doing. Poof, there we go. Okay. All right, so this is the time here. 6:59:20. Are you able to copy those down, Darrell? This red ascension declination?
Give me just a moment.
Yeah, I don't have I can't do it right now.
That's fine.
All right.
I read today that
looks like it's in Orion, huh?
I believe Webb is actually in Monticeros now.
Is it all the way? Is it further east? Okay.
Well, yeah.
Oh,
you know,
6:59. Yeah, 7. Okay.
It was in Orion when it was added out, and since it's going to stay parked relatively opposite the sun in the sky from Earth's point of view, we're going to see it advance over the course of the year at about the same rate, you know, that the sky shifts. And so it's moved from Orion to Monticeros.
Yeah, one thing it doesn't give is the magnitude of the brightness. I'd like to know what the brightness is, but keep in mind we got that big tennis court size sunshade that's always facing us, effectively. So that's going to make a bright object, but it's still going to be, it's 1,000,000 miles away. So imagine trying to see a tennis court 1,000,000 miles away. We wouldn't be able to see a tennis court on the moon. So, not from Earth. So it's going to be pretty dim. We'd have to actually just probably expose for a really long time. And then you might see stars, and then one thing that's a little bit oddly shaped, and that's going to be the moving James Webb telescope. No, I got the arrow. Thank you, James. I dropped it down. Darrell copied down those coordinates, right?
Yep.
All right. So that's cool. Thanks, James. That's why we have the smartest people in our streams, man. I tell you. Okay, we are 29. We're about to do a 30th. Okay, a stack of 30, and then we're done. The telescope, of course, guiding like a champ. All right. So let's go in here. When we get to 30, we got it. Now we're going to pause. Save the FITS file for those who want to do their own processing. That's what that's for. And we'll save exactly a scene for those who want some pretty pictures. And then we'll clear this later when I come in with the next object. But right now, let's go and get back down to our finder view, basically. It's not really a finder view. It's actually like a, I call it a hyper view. It sort of gives us a live view of the sky. Okay, even in 1 second, this nebula shows up. I mean, that's pretty good for the camera. All right, now what we can do is go grab our planetarium program and see what else we want to see right now. All right. Hey, we haven't done the Flaming Star in a while, and it's right here.
Yeah.
Yeah. Why don't we do that? Right down here is the Flaming Star Nebula. The Flaming Star Nebula is a really cool nebula, and you'll like it even more because of the fact that I explained to you the difference between the red nebula and the blue, because this nebula has them both, and it's really cool. You know, so we're gonna go to one of the stars here nearby, and what star is that? I can't tell what it is from looking at this right now. It's gonna tell us. Okay, Hassal. Don't give me a Hassal. Actually, give me a Hassal. That's good. So the telescope centers Hassal automatically. And it knows where to go exactly from Hassal. It calculates the direction to this object, which you can see. This object, also in the constellation of Auriga, it's Auriga, right? Why did I just get a mental breakdown? This is Auriga, the Flaming Star Nebula. And you'll notice in just 1 second we can see some really interesting modeling and colors in here. So let's go and turn this into a... we'll do 25 seconds here. And we'll come off of our hypered view and go into our stack. And we have to clear the last stack. And the last stack was the Northern Trifid Nebula, so we'll clear it. It's really pretty though, and it's been saved to the server, so it's up there. Okay. And now, check this out. This is really cool looking. All right, this is the Flaming Star Nebula, and it's one of these nebulae that has a little bit of everything. All right. Now, by a little bit of everything, I mean you look at it and you see this beautiful red hydrogen emission. This is what we talked about before, the hydrogen atoms absorbing ultraviolet energy from nearby hot stars, and their electrons bouncing off the atom and then recombining with the atom and giving off this red light. But then in the middle, and I'm going to zoom in even though we don't have the data yet to support it fully, we'll still be a little noisy, but I want to show you this. Now we have these weird looking, these are beautiful little blue lines. You see them? And this especially, look at this. This has like a red hydrogen emission line, and then right behind it is a black dust cloud. All right. This is an example of a mingled dust cloud. It has hydrogen in it, and it has this dark material. And the dark material is denser than the hydrogen gas. And so this dark material, it's bigger. Each of the particles are bigger. So on the back side, you can still see some of the black, but then on the front side, the hydrogen emission can show through. And it's going to get better and better and better as the exposure goes on. I also have a focus system that uses temperature to focus. Right now, our focus position is 48,255. It just changed to that. Now it's at 54, then going back and forth. And based on the temperature, it changes the focus because the focus changes with temperature. So effectively, the telescope autofocuses itself. which is also very good. Very good thing. Hey there, Trish. How are you? Nice to see Trish. PG, I did say hi to you, didn't I? I think I said hi, Petita, in the message. I don't think I said it out loud, though. Petita, I think you bought one of my books, didn't you? I don't know if you read it. I don't want to put you on the spot and ask you if it was any good. Probably not a good idea.
Reading rots the mind.
Yeah. Right.
Oh, that was a slogan of a bookshop that used to be here in town.
Wow.
They sold T-shirts that said "Reading rots the mind."
That's funny. So this star right here is your culprit. Okay, this star here is very bright, and you can see that the areas where there's a lot of dark dust but relatively little hydrogen is an area where the dark dust will do what we talked about. It's going to scatter the blue light from this one star, and that scattering means that the blue light goes in every direction, so we see a little bit of blue, little tongues of blue here and there. But in areas where we have more red, or more red, that's areas where there's relatively more hydrogen in that region. And so you can see in this particular region, there's more hydrogen than there is just dust grains, although it's all mixed throughout here. But proportionally, there's more available to us visually. Yes, Sharp Cap Pro. That's what Darrell's correct. Yeah, I don't use K-Stars. I use Sharp Cap Pro. Sharp Cap offers, I don't know if K-Stars does, but Sharp Cap allows me to do plate solving, which is the telescope can automatically tell you where it is in the sky if you lose your place, and sometimes that happens. I'll give you a little story. When Darrell and I first worked on the telescope together, I would bring him along. He wanted to come along because this is exciting stuff, and he's been in here since the ground floor of the opening of this observatory with us, and we were, the telescope's all aligned. We have to align. The telescope has to be perfectly aligned to the North Pole. The telescope has to be aligned to the sky, to your time. You don't want the telescope facing down to the ground, or worse, going into a position where it can damage itself, So you have to align the telescope with the North Pole and the sky. Well, sometimes we would turn up the telescope, turn on the telescope. I would turn it on, and it's like Bart Simpson. Nobody saw me do it. You can't prove a thing. And the telescope would be all confused, and we wouldn't have any data at all. We wouldn't know where we were. So I literally would have to move the telescope around until I found something I knew, and then put the coordinates in manually and say, sync, that's what we want. Synchronize. And that kind of process would take sometimes an hour, and it was really, really, deflating to have to do that, and it happened a number of times. So I implemented the plate solving, and I loaded special databases onto the telescope out in the desert. I made a special trip out there just to do this, and by the time I left, the telescope would never get lost anymore. It would always know where it was, and if we lost our place, which just happened the other night, I just plate solved. In that particular case, it was like 20 seconds later, I had the exact coordinates on the center of the frame, and I put them in right up here. This tells the telescope where it is. I entered them here, and these boxes, right ascension is the left to right motion, east-west, and declination is the up and down. And I tell it what to do, what the coordinates are, and then I say sync, and it goes, and it changes the numbers. Boom! Now the telescope is aligned again. That was down from having to mess with it for an hour. I thought that was pretty good.
It was basically just a software conflict, wasn't it?
Yeah, it was a software conflict in the telescope. When he first installed this telescope, oh man, the telescope was not originally going to be an F2 instrument. This is an instrument now; it's an F2. You see that big long, this big long. No, keep doing it again. This big long, right here. This big long object right here. That's a dew cap. All right, it's meant to keep dew from forming, but it's also a protector. It's actually metal. It's a metal sleeve fit over the end of the telescope, and it's actually protecting the camera. There's a big camera in there along with a massive lens, and that took the telescope from an f8, which is like a typical astronomical telescope, and brought it down to f2. Now, what does that mean? When you look at cameras, you take pictures. F22 is the tiny little hole on your camera's opening, and F2 is the biggest opening. You know, some of them go to F1, okay, F1.9 or whatever. But F8 is around here, but F2 is way out here. That means that this telescope is about 25 times faster than its F8 original design. So that's why we can take pictures of nebulae like this in 30 seconds. All right. Sometimes it takes hours to get shots like this. You don't want to sit here for hours. I'm doing this because I want to give you guys something to look at and go to the next, to the next. Make it a presentation, make it a showy thing so that you can enjoy it. You know, little music in the background, you know, you can go clink your wine glasses while looking at a 60-inch TV screen and watching a nebula develop in front of you right before your eyes, knowing that it's a live image. Now, that's the cool part. I just think that it's very cool. I don't know. It's just, it's something I've always wanted to do, and I just can't shut up about it. And Darrell saying, yeah, shut up already, I'm sure. But, you know, he's being kind.
I didn't say anything.
Nobody saw me do it. You can't prove a thing. Right. Yeah. Amateur equals for the love of it. Yeah, that's right, Science Bob. No doubt. However, I also did it as my vocation. I have a degree in astronomy. That's what I went to school for, which is why I just don't seem to shut up about it. I find myself wanting to talk about the origins of these clouds and where they came from and how these stars form. I mean, I could go on and on. So it's pretty cool.
Maybe you should switch to decaf.
I don't drink coffee. That's the problem. Can you imagine if I did? Wow. That'd be bad. That's a scary thought. That's a very scary thought. Oh, man. But I do want to give you...
Let's all chip in and get Marc an espresso machine for Christmas.
No! Oh my gosh, no. No. That would not be good. James, yeah, 60-inch screen, I wish. Yeah, I know. That's I had someone watching the other night who said, I got you up on the big 60-inch screen. It's like, wow, I really was curious what it looked like there. You know? Uh-oh, got a troll. Gotta eliminate that one.
Uh-huh.
Yeah.
I must be lagging a little bit.
You might be. Thank you, Izabela. I believe those are bots. I was told that yesterday or the day before in the stream that those are bots.
Yeah.
Yeah. I forgot who told me that, but I wanted to thank them. I forgot to say thank you. Wow.
Myself, I think it's Putin.
You mean Putin?
Whatever.
Oh, okay. Science Bob says it's fantastic on my 72-inch LG. Oh, okay. That's cool. Yeah, so this is now a really nice photo developing of the Flaming Star Nebula. Called so for the obvious. Okay, it looks like flames rising up here from this star. It's a region that is a very interesting region. It's actually just north of another region that we should look at, which I will show you. It's the letter Y cluster, it's called, but it's this area right here. And this is another area in the sky that's really cool, and it's right near the Spider and the Fly Nebula. Okay, these are all things that we just could not see very well from the east coast version of the observatory. We have Skytour East and Skytour West. Skytour East is going to be put back in place, but it's going to be more of a research facility. And Skytour West is our public outreach observatory. And we've got another instrument going in out there that's going to afford us, because Darrell's been yelling for it, more focal length, so we can actually close in and look at objects much closer. All right, and see one view, the wide angle view, and then see the close in view with the other telescope. So at the same time. So that's going to be kind of cool. That's going to be a miracle to pull off, huh? 2 telescopes running simultaneously in sync at the same time. Sure. That's gonna call for a manual to start up. Hey, Dagger. I wrote a manual for this already anyway, in case, because the time's gonna come where we're gonna actually have another pier in addition to the second, and that one's gonna be a rental pier where people can rent a telescope and just go have fun, go check things out. And the telescope won't be able to go to places it's not able to go to. It won't, no damage, no nothing. So that's kind of cool. So even people who don't know what they're doing can just pick objects and say, let's go see that, let's go see that. But you only see objects that you can actually see with a telescope at that time. Really cool stuff. All right, this is... okay, we're at 33. That's more than enough for this. We're going to say pause and save. And you'll see our thing up there. I've got one other thing to do, by the way, to enhance these images, which I haven't done yet. But I'm going to do it now. Okay, so just a second. All right. So just to remind you, this is where we are. This is what we're looking at. It's the Flaming Star Nebula. Forgot the caps, I'm sorry. But what I got to do now is just add one more little feature that I didn't do before. I'm going to come in here and go to Enhancement. I'm going to add the unsharp mask, Darrell. So I'm going to do this. This is now going to sharpen it up. Now watch the screen. Okay. Look at that. All of a sudden, everything is sharper. You see that? It's all sharper now. And we've actually been able to just... It helps to sharpen everything so you can see what you're looking at a lot easier. Really, really nice. This is great. Okay. Now, we can... I'll save this again. I don't need to save the stack that way. I just need to save the image. Exactly as seen, so the sharpening is included. Okay.
I have a question.
Yeah.
There in the second box from the left, right next to where you hit save, it says stacking, sigma clipping. What is that?
Sigma clipping is... Okay, I'll show you what that word... I'll show you what happens here. For sigma clipping, you have default and you have sigma clipping. This determines... it determines how the stack is going to be... I think it's for the alignment. I got to go back and look. And you can actually...
Well, maybe I think you can... Time.
I should... Well, that's the thing. I got to show you. And there's some settings you could look for. I'll go through that when I have a better understanding of that. But sigma clipping is... Go ahead.
Carry on. I don't want to detract from the stream.
Well, you're not. You're not at all. You're only asking what other people probably are thinking. Okay. All right, so now what we're going to do is we're going to clear the flaming star. Almost seems like a sin to do that, considering that, it's so beautiful. It took all that time to show up, and now he just gets rid of it. But I didn't get rid of it. It's actually out there. And what I'll do is go to auto here. So there is the full screen. All right. And I want to do 1 second again. All 1 second with our hybrid view now. So now you see 1 second images. And again, as you see, even in 1 second, you can see it, you know. Izabela, thank you so much for putting the addresses for the server out there. That's very kind of you. Michael Klager says, I'm going to rent time at my local observatory. You know what? That's pretty cool. We're also going to offer rental time as well out in the desert. And I think that with our Bortle 3 sky, it's very, very dark, as you can see. So if there's a time, if you want to rent time on one of our scopes, we'll be happy to do that. You can even rent time on this scope if you want to do F2 shots, and we can tell you how to do that. It's a service we offer. And you know, you're in charge, you're in control, but I might operate the scope just to keep that, keep you from having to do it initially. There'll be a time where everybody can just operate the scopes, but it's gonna. David Schmidt, how are you doing, David?
Excuse me.
David is in Thailand, which is why he says good morning. Wow. Oh, there's so many people you might have missed. You know, David, it's okay. You know, there's just people come and go, you know. Isabel says, gee, I can't stop thinking that I'm on a spaceship. Well, you are. You know, we always talk about spaceship Earth, but effectively, we are on a spaceship. We're just trapped around the sun. We can't go further. We can't leave. And it's a good thing, because if we were just rogue planets, we wouldn't last long. Okay. Let's go over to our view here, and let's head to this little guy. We're going to go to the letter Y Nebula. Believe it or not, you're going to laugh. I've never looked at this nebula before in my life. Letter Y cluster. I could just drop down with the telescope and probably look at it that way, but I'll let the telescope drive itself to it. I want to see if it knows where it is. I've discovered that some of these objects in the telescope, it really doesn't know where they are sometimes, and it ends up in the wrong place. Yet if you move to where it's supposed to be, it's there. The coordinates are wrong in the database, which I think is interesting. You know?
May I ask a favor?
Yeah, sure.
If you can go back to Stellarium.
Yeah.
All right, stay where you are, but can you back out some? I just want to get my bearings.
Okay, we're in the middle of Auriga.
All right, yeah, I see from the other stars there.
See, there's Elnath on the right.
Very good. Okay, thank you.
And Hassal. Okay. All right. So now we are right by the letter Y cluster. All right, which is here. And you can see this nebula, right? And you can see the other part of the flaming star up there, actually. But the nebula is here. Let's take a look at this nebula. Before we do that, actually, let me move us a little bit more this way. I'm going to go south with the telescope just a little bit. All right. And then we're going to move the telescope just a little bit to the east. Yeah, that's right, James. Yeah. Daytime there is nighttime here. I actually used to have time on a telescope in Australia. And that telescope ended up getting closed down. So I couldn't do it anymore. But I actually really enjoyed southern sky views. And we're also looking, if anybody down in Australia has any land that they would rent us or let us use, we would consider putting an observatory down there. It's an excuse to go down to Australia, yes. But I gotta tell you, though, that in all honesty, that's not something we can do until we have foundation support or something like that. Unless all of you want to, like, send us, money every month, which is crazy. That's, I think, what the Patreon thing is. But I think I want to go try and get someone else to pay for it, and then just let you guys be the recipients of it, right? Why not? You know, I think it's cool. All right, let's do some photos here. All right, so this guy right here, this is called the letter Y cluster in Nebula. All right, and I'm not sure. I'll get the actual designation of this in a minute. All right, so where we're going is right here. This is where we are. All right, and let's take our time here and go up to 30 seconds. Only you can prevent forest fires. That's funny.
I have CRS.
Yeah, right. Mm-hmm. We won't say what it means, because there's kids here sometimes. Okay. So here's the first exposure coming in for the letter Y cluster. And let's see what it looks like. Wow. Hey, look, see what's there? There's a lot going on there. There's a lot going on there. First thing I'm going to do, though, while we're waiting, is I'm going to go to 100% and check my focus, make sure that we're still doing well there. Needs a mild adjustment, so we're going to... I've been refining this as time goes on, so I'm going to clear this, come back to this. We'll come back to this in a moment. Do a 1 second shot, and then do this. As you can see, when I do that, when I pull this down, you can see that see that weird look right there and right there? That shows us that the telescope's slightly out of focus. And I want to change that. Hey, Donald, thank you, man. So, let's do this. Okay, so we're going to look at this star. Let's try, first of all, let me get off the temperature dependence for a second. 50 degrees. In there, 50.9. Temperature's dropped about 10 degrees since we started. All right. Let's try going down a little bit here. I don't want to go down a lot and then just see what we get. Okay, that's the right direction. As the temperature drops, we have to drop the focus down. Okay. That looks pretty good. All right. Now we'll turn back on the temperature correction, and it will start from that set point. All right. And away we go.
David and Izabela, I recall when I felt the most like I was on a spaceship when I was looking at the night sky was during the peak storm year of the Leonid meteor shower.
Oh, yeah.
And Leo was well up in the east. I was facing directly into the radiant point, which is right inside the sickle asterism in Leo, backwards question mark. And the meteors were just streaming out of it. And it was just like standing on a bridge at the Enterprise at warp speed, you know, when you see the stars flying all around. It just such a sensation of like being there and just flying right into the middle of it. It was amazing.
Wow. Donald, thank you. That's very cool. Okay, we're taking a picture now of this nebula again. And, oh, I think I should have live stacked it. That would have been better. Yeah, that was dumb. Okay, let me clear this. And now the images are going to be even sharper and clearer. Donald writes.
Still
Hold on. Donald writes this. Wait a sec.
I'm sorry.
Donald writes.
Carry on.
That's okay. To see the Coal Sack, the Southern Cross, and the Alpha Centauri suns. Yeah, I've never seen any of those things. Actually, I saw the Southern Cross when I was in southern Florida. I saw the tip of it just above the ocean. It was beautiful. I was like, wow. Really, really incredible. Go ahead, Darrell. I'm sorry.
I'm sorry. Were you down in the Keys?
Yeah, I was way, way south.
Yeah.
All the way Key West.
Is that the big star party they do down there?
No, believe it or not, I was there to actually photograph Halley's Comet.
Oh.
I was, as an astronomer, I had people I knew that wanted to go photograph the comet, and I got calls saying, "Come on, we're going to Florida." I go, "I can't go to Florida. I got working. I got this, that." I go, "No, we're paying for your ticket. You're coming. You're going to do the photos with us." They wouldn't take no for an answer, so I effectively was kidnapped by a bunch of friends, and ended up going down there. Actually, there's one friend I have named Jim. Great guy. The guy has been a good friend of mine for many years. He's an amateur astronomer. Never stopped looking at the night sky. Never stopped loving the night sky. And it was Jim who finally said, "Come on, we're going to see Halley's Comet." And I told him I couldn't afford it. He says, "I've already bought your ticket." He literally had bought the ticket already without even asking me. And then said, "Come on, we're going." And I went, "All right." So I told work, I'm going to be gone for a little while. And then I was gone for about 4 or 5 days. And I have to say, I've never seen a more beautiful sight. It was really gorgeous down there. Oh, see, Vera, she's in Rio. Okay? She's in Rio. And so she knows what we're talking about. She's seen it. That's fantastic. Yeah. Look at this.
So this is called the Y cluster.
Yeah, but I'm going to go into Stellarium, and I'm going to add the designation for this, which is... I got to come up here a little bit. Okay, so this is where we are. Yeah, that's what it's called, but that's not what it is. Okay, that's just the cluster of stars that's in it. What I have to do is come here and turn on the catalog so we can actually see what we're looking at. And I'm not sure if one of these is the right one, but these are the ones I typically use. Let's check it out. Let's see if that added it in. Did it add it? I can't see it now.
Michael, yes. Comet Leonard, I looked for it quite a few times. I never could catch it from here in Colorado. But it just got better and better down in the southern sky.
Okay. All right, so the tadpoles. Yeah. And the tadpoles in this view are... there's the cluster. I think we're upside down. But...
Well, I see sort of a Y shape in there.
Yeah, but let me...
stars.
But what I'm getting at is I think that our view here, if we look at this, you see how it's shaped? All right. The top is to this side, to the left. And I think the tadpoles are up here. So we should see them at the top side. Let's check it out. So there's one. Wow, Raymond. Holy cow, you must like the tadpoles. Bounty from Marc said. Oh, that's so funny. Hi, Charlotte. Wow. Thank you, Raymond. That's so kind. Thank you very much. Wow. bounty for Marc's head. Now that's a new one. I haven't heard that yet. Hope there's no takers. Charlotte says, Marc, I used to live in Argentina. My dad was fascinated with the night sky and helped us learn about Orion and many other constellations. And the best thing we ever saw was always the Southern Cross. You know what? I don't doubt it. I don't doubt it. The Southern Cross is beautiful. Crux, it's called. It's beautiful. And I'm just astonished by how much it looks so beautiful. And from where we are here, I don't believe we can see it. But I'm going to look for just how far off we are, because I'll tell you this. Right now, the telescope you see over my head here, that's on a fixed pier to the ground, okay? And that fixed pier to the ground is getting replaced. It's getting replaced with what's called a lifting column. That lifting column is going to take the telescope up above the walls of the observatory. So the observatory needs protection, right? The telescope, needs protection. And the telescope is protected by the walls. And they also serve to block what the telescope can see. Right now, in a fixed pier, it's blocked. I get down to about 25 degrees above the horizon. And normally you don't want to see. That's what the design was. That's what I designed it for. But normally you don't want to look below that because you get interference from the air and stuff, and objects don't look that good down that low. But as I've found, the air quality out here in the desert is exceptional. And you can look down low in the desert and still catch some amazing sights. So I've decided I'm going to take the telescope and put it on a column which is going to lift it up in the air with a hydraulic lift and bring it up just above, so the whole telescope will be sitting above the walls of the observatory. Now, you've seen the roof come on and off, and if the roof went on now, it would just cut the telescope off, right? Well, there's a fail-safe in the telescope where I cannot shut the roof at all unless the telescope is in a down, parked, and cleared position. So the same thing with that rising column. The telescope won't be able to close until the column is down low. And the way it'll go is the column will have to raise first. Then the telescope will be able to move around, do its things. But then what you do is you have to bring the column down, then you park the telescope, and then you can shut the roof. There's a certain order that you have to follow, and it's going to be programmatically. It's going to be done with the program. I wrote a program, which this little white box down here that you don't really see much of. This is access to my program. So the first thing I did was I opened the observatory, and I just put little numbers just to make it easy. And they turned on the pure power. And after that, it's all on all these applications that I bring up. So that's pretty cool. So let's see now, Darrell. Where are these tadpoles? I see where it says the tadpoles. I see these guys here. 3 or maybe 4. 1, 2, 3, 4. And if we are looking at this correctly, then they should be on the right of center. Oh yeah. 1, 2, 3, and possibly 4. Right?
I'm tilting my head. Go back to Stellarium, please.
Oh.
Yeah, I think so.
Yeah.
I think your image is rotated 90 degrees clockwise to Stellarium.
That's correct, because if you pull out here and you look at the telescope field view, you can see that the telescope field view is 90 degrees. You'd have to rotate it. You'd have to rotate your head counterclockwise 90 degrees. See?
Oh.
So yeah, so this is flipped over that way by 90 degrees, left to right. And that's what we got. So that's the tadpole, and this is the Y cluster right here. Why is it a Y? Maybe because of this right here. Right here, that's the Y. I'm not sure.
Can you zoom out all the way on your image?
Sure I can. We're at 33% now. Let's go to auto, and we'll pull it all the way out.
Yes. The pairs of stars over at the upper right. Yeah, those correspond well with the stellarium also. You got that pair at the top, then another pair to the lower right, then
Yeah, so
another
let me go
bright
this.
one farther down to the lower right.
Right.
And that matches up also with stellarium.
Here's the
See,
pair.
there's the first pair, second pair, bright star,
And I
third
got
pair.
these three. Get this one
Yeah.
down the bottom. We
Yeah,
should have one
that'll-
right down the bottom.
That all corresponds.
Yep. Good. Yeah, I like having I like having it set up in stellarium so you can actually see the exact orientation of your field. That's important. So let's see. We've done 25 of these. That's good enough for this. So these are the region of the Tadpoles Nebula. It's a dark nebula inside of an emission nebula, which is kind of cool. And so these are actually the Tadpoles.
Mark, excuse me a moment, please.
No problem. All right, and then we'll save this exactly as seen. Okay. All right. There we go. All right, and now we'll clear it because it's been saved. We'll get rid of that. We're not going to stack now. We're going to go back to 1 second. Are you guys having as much fun as I am? It's really kind of fun, isn't it? I'm really enjoying this. Judy McClellan, hi, how are you? Welcome to SkyTour Livestream. I don't remember seeing you before. Feel free to subscribe to us. We show the universe dynamically in real time. Really cool things that we show. And there's a lot going on the screen. If you haven't been here before, you'll pick it up. But if you don't, I'll be happy to share it with you and tell you what's going on, as will everybody else. All right, we'll get rid of this. This is where we were. All right. But really quickly, this is the telescope control system here. This is the telescope in the building. All right, this is me. Hi. Over here is the camera controls. Okay, which is, okay, this is the telescope control here. Telescope in the building, me, the view. And then over here on the little fly-out window, this is the camera control system. We're using a dedicated camera control system. We're running at -10 Celsius on the sensor of the camera. We're actually really, really frigid in there with the camera. And that keeps our noise down. I'm glad you've been watching for a while, Judy. Thank you. I'm glad you were compelled to actually write and say hi. That was nice of you to do that. It's nice to see you. Nice to meet you. And you're in very good company here. A lot of the people here, they will help you every step of the way too. By the way, as you probably noticed if you've been watching for a while. I'm an astronomer. That's what I do, as you've heard. So I tend to really get into some of these things here. All right. Now we're just going to drop down a little bit more, and we're going to go look at the Spider and the Fly Nebula. This is a really cool location as well. But we'll focus on the Spider and then center the Fly in here. And as I said, I could just steer the telescope down, but let's just tell the telescope to go there. This is all part of my testing process for the whole software and everything. So you can watch the telescope move a little bit over my head. It won't move that much because it just has to go find a star. You can see a little bit of movement there. It's finding a bright star, and it uses a signpost to where we're going. And then it's going to basically find its way, calculate its way from this star right here that it's currently bringing in. And that star that we're looking at is It's one of these stars. Which one? I don't know which one that it picked. Okay, that's okay. All right, so now we're coming to the Spider Nebula, and I see that cluster too. I think that's the cluster we're just looking at. Let me just check that out for a second. All right, 1 second. Okay, this. All right. So this is the field of view, and basically you got to turn your head far over to the left and you know, kind of be like that a little bit. But I'm going to just take a exploration photo right here of this location. I see something over here, but we're going to check it out. It might be a galaxy, I'm not sure. We'll just do a quick 25-second shot, and we'll stack it. I want to make sure that this is the location I want to be in, the Spider Nebula. Again, I keep finding bad coordinates all the time. Lucky me. That's all right. Hey, weird guy, how you doing? That's funny. Some of us rent a room in Mark's head, or is it the other way around? That's funny. Oh, look at all that. That's beautiful. Let me drop this. We're actually really overblown right now but it's good. It helps us to know what's actually all there. So we'll drop it down. Okay. And that is the Spider Nebula right there. And I think that's the starfish cluster up there. So we're it might be the starfish. I don't know. Looks like it's too far up there.
Yeah, starfish is over to the left there on Stellarium.
Yeah, but that's, remember, look at the orientation.
Oh, right. Okay.
So it'd be up, but I'm wondering if there's a fainter cluster in here that I'm just not seeing. Might be. Oh. Okay. All right. Yes, it's this we're looking at. NGC 1907. Okay, good. Because the starfish cluster is not in our field of view. And I was like, hey, what's going on? But if you look at the Spider Nebula, all right, the Spider Nebula is here. And then the fly is here. Our guiding is off a little bit because I was moving the telescope. And so I'm going to clear it. Go back and center at 1 second time frame. All right, and then we'll come back. And we're going to get rid of this for now. Okay, good. And now we're going to do our hybrid view. All right, now what we do, so that's actually the Fly Nebula. So we're going to drop down. All right, which means take the telescope south a little bit. All right. Okay, and then we're going to actually move the telescope a little bit to the east. All right. This is really kind of cool, right? Because this is all happening live. Yeah, and you know, seeing things like this live in a few seconds, I don't know who else is doing it. I just don't know who else can do it or is doing it. Anyone could do it if they actually took the time. You know? Okay. Telescope is settling down and it's going to find a guide star. Takes 11 seconds for that to occur. I wonder if it's windy out there.
colder than heck
Okay.
here.
Yeah.
Y'all have another storm coming your way to the people in the Midwest and the East.
I know. This
It
weekend
hit
they said
here
nor'easter.
today, and the snow missed us as usual. It hit just north of here, but
Okay.
it's getting really cold tonight.
All right.
And
All
the
right. Here's
storm
what we're gonna
itself is
do.
moving on east.
Okay. Well, I don't want to hear about storms right now, man. Okay, we're live stacking this, and we're doing 35 seconds. I'm clearing this past shot because it wasn't a good one. And the stack's been reset. So now we'll see what we get. Our sensor is still at negative 10 Celsius. Everything is good. So let's find out how it looks, shall we? Okay, we need to... I think I got wind right out there. I think we have wind out there now. So I'm going to have to work on that. It just means I'm going to end up... Okay, just got to do one thing here. I got to move this guy. There we go. Put that up there. All right. And all right, so we're gonna clear the stack here because in that time, oh, you know what else I can do? I can do something else too. I can go into our our amazing guiding system and alter the guiding system a little bit. All right, let me just do that. Okay, first of all, let me just get things straightened out here. I've got a couple of things that are not quite lined up right. Yeah, guiding system needs to be altered. 1 el segundo, I'll fix it. This delay you see on the screen, that's going to be gone with Starlink. All right. So now, okay. Status. I'm going to go down now into the telescope computer. You can see me going in there. I'm going to set a rate of correction for our east-west motion. That's the left to right. And that's going to be at 05. All right. It's going to do like 5% corrections. And then I'll go down one more. And now we're going to do the up and down, the declination rate. And that is going to be set to 0.1. 66 is just way too much. So, that said, we're good there. And now what I'll do is I'll take this picture again. And if we don't have a wind problem, then this next photo that comes in should look stunning compared to that, which is streaked in the upper direction there. So let's find out, shall we? Let's see how we did. Of course, it was guiding part of that, so this one also might be streaked. Yeah, I gotta clear it one more time. Otherwise, there's wind blowing, and I know there's some wind that's gonna happen out there. And if we're getting wind, well, then we're gonna have this problem all night long. But I am determined to show you a few other things, so we'll make our way through it, guys. All right, let's see how this looks. Yeah, we're still getting it. All right, we're getting a little wind blowing us around, so we can abandon this one. I'm okay with that. And I think I want to move a little more in the direction of Orion. All right, come on. All right. Yep, internet is becoming slower, as you can see. Okay. All right. And when that happens, I end up having to reset things. It's a weird problem that happens from time to time, so I don't know why it happens. Why are we slow? That's what I want to know. Okay, we just got disconnected twice and reconnected twice. And I'm not sure what happened, but I'm going to do my best to figure out what I can do here to get out of it. 1 second. Let's see if this is actually even connecting. All right. Let's see if we can move this over. All right, so we have control. I have control. All right. Now let's move it over. All right. I'll be happy with that for now. All right, folks, just a minute. And then
You've
this
lost
guy.
the telescope?
Nope. I have it. It's just that it's doing it's got a really slow mode right now. I don't know why. So I have it back though. Okay. Let's zoom this out here. And let's get to Orion before it goes haywire on us. All right, and let's get this up here. All right, that's good. I just don't like the delays. You know, the satellite, it just, we're so delayed by the satellite that it's crazy. Sometimes it goes away completely and we have a perfect night, and then other times it just makes us crazy. So sometimes that happens. But all right, it looks like we're back. So now what I'm going to do is just make sure that all of my data panes are where they belong. Okay, that looks like it's where it belongs. A little more this way. You know, presentation has to be good too, right? People have to like what they see. All right. Then I can take this, move it over. All right. And now this guy, Stellarium. Let's go over now back to Orion. And I want to find out where we are with Orion right now. Make sure that, okay, we're high enough now that we can go check out Alnitac. And that's what we're going to do. All right, so Alnitac is selected. I'm going to come back here. We're going to check out everything that's really cool over here. Don't worry. All right, I'm going to clear this. The wind is getting us for this exposure. Hopefully it's not too bad elsewhere, but it might. Oh no. Okay, now this guy here. Let's go down to 1 second. Do our finder mode one more time. I think it's pretty cool that even when things go really wrong out there, we're able to troubleshoot it from 2,500 miles away. And so far, I've been able to fix pretty much everything that's gone wrong remotely. That's really cool. Hey, Rascally, how you doing? Yeah. All right. Here we go. That's the Spider Nebula and the Fly Nebula. But now we're going to go over to the Horsehead and the Flame, which are just stunning. So here we go. Tell the telescope to go. You're going to watch it move quite a bit up here now. Here it goes. All right, and it's probably gonna go to. If I don't miss my guess, it may go to Betelgeuse. Oh no, okay. I'm not sure which star it's going to. We're gonna find out. It's not going to Alnitac right now. Yeah, Bellatrix. That's weird. Alnitac is one of the primary bright stars. You would think that's in the database. It should go right to Alnitac. If I tell it to go to Bellatrix, it'll go to Bellatrix. If I tell it to go to Betelgeuse, it'll go to Betelgeuse. But Alnitac, it doesn't want to hear it. So from here, it's going to go to Alnitac. That's okay, as long as it gets there. That's important. Oh, you saw that In Search Of episode, Tim F? Yeah, I shot that in Boston. They had me come up from here, from Connecticut, to go to Boston to shoot that. That was cool. I never got to see the finished thing. I hope it looked good. Okay. So you can see right now, you can see the Flame Nebula here. And you can see the Horsehead down here. And what I'm going to do is I'm going to take us down a little more here. And we got to hopefully make sure that there isn't a wind at this point. We have a slightly lower angle. When you're up like that, that cover on the telescope, that big cylindrical cap, catches the wind pretty good. You know,
like a sail.
It's a sail, man. You got it. Of course, Rascally. I'm glad you're here. All right, let's bring this up. All right, that's a little too much, I think. Well, I don't know. Let me just drop it a little bit. All right. Alnitac is a bright O star. You can see it's one of the hottest and bluest stars there is. That wasn't there, as I mentioned, when Lucy was in Olduvai Gorge 4.2 million years ago. This star is about 4 million years old. And the next star up, of course, is Alnilam, and then Mintaka is the third one. This star down here is Sigma Orionis, and is causing this part of the nebula to glow. Alnitac is causing this Flame Nebula to glow. All right. Okay, I noticed. You see that? It started to shift. See it moving around? We're getting some wind. You can see that. The telescope's not just randomly moving. Okay? The telescope is locked steady. So this shows you how much is going on out there wind-wise. We're getting some pretty good winds out there. Yeah, there's some big... Look at that. That's really good wind. And you know what? Winds will close us down. Wind will close us down. So... usually the wind occurs right after sunset. And then it dissipates, it deviates, it goes away over time. But it's 9:37 out there now. And as you can see, it's still, the telescope is staying where it is, but it's bouncing up and down because it's being buffeted by wind. So that's not good. We didn't even have a clear view. Yeah.
Well, that is getting bad.
That's pretty bad.
I looked at Weather Underground for Wickenburg a couple of minutes ago. Weather Underground is notorious, well, in my experience anyway, that I can check between it and National Weather Service.
Yeah.
And Weather Underground will say 2-mile-an-hour wind, and National Weather Service will say 38-mile-an-hour wind. But I looked at Wickenburg just a few minutes ago, and it said 0 wind.
Well, that's Wickenburg. We're not near Wickenburg. I mean, we are, but I guess as close as anything in Arizona could be, right? I mean, Wickenburg is 20 miles away. Let's see if this actually captured it. I got to remove the high. Yeah, look at that. Oh, and here comes satellites. We always get satellites, and you'll see them moving right across the screen here. Yep.
Happy Hours Day, James.
Happy Australia Day, everybody. Yeah.
Let's all sing Waltz and Matilda to James.
That's right. Tie me kangaroo down, sport. Tie me kangaroo down. Did you hear that before, James? I'm sure you have. Well, there's the horse head anyway, and I find myself feeling bad that we got wind, because that's going to prevent us from getting some really good shots of it. And unfortunately, that wind is not a good thing. You don't want to keep a telescope exposed to wind, because the wind is also blowing particles of dust and everything. Let me clear this and see if I can get a clear shot here. Nope. Yeah. Didn't expect this tonight. The wind just kicked up.
Well, that sucks.
Yeah.
Or blows, depending on your point of view.
Oh, that's funny. Yeah. All right, so let's do this. Now let's do our 1 second exposures and hyper it out to see what we got. And zoom in to watch what's going on. Let's see if we got some calm. Isn't this amazing? Yeah, Rolf Harris. Yeah, we knew Rolf Harris. Yeah, Rolf Harris had his own little weird issues later on, I heard. Which kind of was depressing, because I kind of liked him. Rolf Harris is the Australian who had a lot of really cool songs, fun songs. I think I threw away his music after I heard about his problems. Yeah. We're getting moments of clarity, but then we're getting this, we're getting these bad streaks. See
Buffeting.
that? I was just about to... Yeah, we're getting buffeting. Yeah. I hope not, Donald. Donald says that's that wind could be the seed of the big storm we're supposed to get this weekend. I hope not. Marty and Emu Rabbit. Yeah. Well, we're not, it doesn't look like we're going to get a break from this. But while we're here, we might as well just see if taking us a little bit south to the Orion Nebula gives us any break. So if we go down below, possibly as we head south, this might help us out a bit. So we'll try it. So we're gonna head now. We're gonna do high precision slewing. We're whipping over. Oh, it's going that direction. It's probably gonna go to Rigel. Or maybe not. Maybe going to Cursa. Let's find out. Yeah, it's doing Cursa. Cursa's a star in this neighborhood. It's going to center it up. Okay. All right, so now, after it goes there, it's going to take us off to the Orion Nebula. And it might get it wrong, because I've noticed there's some database issues in this region, too. Yep. So we should be seeing the Orion Nebula here.
Curse is right next to the Witch Head.
That's right.
I sent you that A-pod a day or two ago, and a different picture also. We should try to get the other half of the Witch Head sometime.
Yeah,
Maybe
you're right. We will.
Stitch the two of them together and make the whole thing.
Mm-hmm.
The thing's like 5 degrees long, the whole nebula is.
It is. It's a big, big boy. So let's go and let's give us a little more. Yeah, so what happened here is that the nebula is very well known, but unfortunately, what happens is sometimes the database is incorrect. And I've been finding lots and lots and lots of errors in the database, and this is one of them. You know, it depends where you are in the sky, and if you try to go to the Orion Nebula from that particular point, it may have trouble getting there. And this is one of those cases where it has. See, here it is. We have it, but I have to steer the telescope toward it. It's really kind of silly. But it's nice to show this section here, because even without taking a time exposure where we have to take a photograph, you can see some really cool stuff in this shot. I'm hoping, yeah, see, that's very sturdy. That's very still now. That's really nice. Let's try it. Let's just try a 2-second stack. See what we can get, because I might want to see if we can show. There's the trapezium in there. Oops, I guess I should probably clear that, huh? That's the last one. Alright, now we'll get it. There we go. Oh, look at that. Even with a 2-second stack, the wind is killing us in Orion. Okay, that's a good one. Look how pretty, guys. Look how beautiful that is. Really, really pretty. Wow. So this is
favorite.
Yeah. This is the Running Man up here. It's got a little emission nebula inside, which is the same as the red nebulas here. And then a reflection nebula. This blue stuff, which is that scattering component I told you about. Scattered the dust particles here. This is all dust. A lot of dust right here. On longer exposures, you can see it. And that dust scatters the light and makes it all blue. So when you have an emission nebula inside of a blue reflection nebula, well, the way light works is red light mixed with blue light will give you kind of like a magenta light. And that's kind of what we see here. Beautiful dark nebula here. Do you see your Bill Murray eating a baby Ruth this time?
No, it doesn't show up at F2. It's
okay.
It's so overexposed that it's washed out.
All right.
We see it all the time at F8.
All right. We'll tell you what I'll do. I will clear this. And what I'm going to do now is I am going to drop the sensitivity of the camera down to 35. Okay. And that's going to be like dropping the ISO, or the sensitivity of the sensor. All right, so that's what we're doing now, and I'm going to clear this, and the next photo should be a little different. There you go. But we have wind. All right, we're gonna clear that and try it again. Okay, that's better. And of course, with the wind, we're just luck of the draw, trying to figure this out if we can get in here. Inside here, those 4 stars that you see here, they're not focused because the wind is blowing. They are responsible for illuminating this entire nebula. They're called the trapezium stars of the Orion Nebula. And let's try a 4-second shot. All right, and we'll do that, and at the same time we're gonna clear the stack and see the difference. It'll all be overexposed in there. That's okay.
Izabela, the same plane. The Orion Nebula is very 3-dimensional. There are videos on YouTube, animations of flybys and fly-throughs of the Orion Nebula, where they pass through it and around it from different angles, and helps you see the 3-dimensionality of the entire nebula. It's not a 2-dimensional object, so I would not say they're necessarily in the same plane.
Right. Okay. I'm gonna do 12 seconds.
Give me a second, I'll try to find one for you. Carry on.
That's right. Oh, I said 12 seconds and it stayed at 4. Okay. Okay, this will be a very different looking photo. What happened there? How come it's not doing it? All right, one more time. I might have actually... Okay, now we're talking.
There's
Let's
a good one
that
for you.
All right. And just like last night, or the night before, we see 3 satellites coming in, one right after another. And it's actually 4 satellites. 1, 2, and there's a third one here that's fainter, and a 4th one there. It's rare that we actually get unobstructed views of the Orion Nebula. Let me actually affect the color. Let me change the color, the proper color settings here. Okay, there we go. And then this guy. Remember, I'm at that lower gain, that lower sensitivity. So I'm going to change that back now. I'll change it from 35 to 135. Let's try that. All right. And now what you see is the next photo that comes in is going to have more detail in it on top of all this. Ready? Okay, see that? It got brighter. All right, now let's change this. Change it now to say 350, which was what I've been using. And then we'll see another change. Of course, we have to acquire at 350, so that's why that happened. All right. That shows you the difference right now. All right, so we'll clear it. Check out all the satellites on this really deep shot. 1, 2, 3, 4, 5, 6 satellites. These are wild. This might be Starlink coming through here. Do we have a Starlink train? I don't think there's any Starlink trains out there now, right?
I just looked earlier tonight. Not in my area, at least, but
okay.
as you mentioned before, Starlinks tend to fly on diagonals, not equatorial.
Yes. Well, when they're first launched, though, they're all straight. So that's why I'm asking: have there been any Starlink launches within the last, I don't know, couple days? I don't think so.
In the last week, yes.
Okay.
There was one last week, which is why I was looking.
Okay, because all these satellites that we're seeing here are at the same altitude. How in the world would I know that?
Because the lengths of their motion are all the same.
The lengths of the trails are identical. That's right. Yeah. That's right. Hey, MLR, how you doing? Charlotte, thank you for coming. I'm sorry you've got to go. But you know what? With the wind, we're probably not going to be able to stick around too much longer ourselves. But we will talk to you another time. Thank you for dropping by. Okay.
Why does your histogram look so squirrely?
What do you mean? On the right?
Yeah, when it was over
the previous
on the right, the white line was really squiggly.
Yeah, it was. Let me bring this down to something a little better. Look at all those satellites. It had to do with the fact that I had the stretch was so deep on the histogram from the live stack. It affects this one. That's why. See, now it looks normal. See, but we can actually take some of this and drag it and see more data that's hiding back there. See that? Look at all that dust. This is what's hiding out in the Orion Nebula complex, folks. And what I want to notice this. Okay, I'm going to let this go because I think this is actually working. But watch this. Let's zoom in on that for a minute. Okay, let's check this out. This area right here, in between this nebula here, this is called the Running Man Nebula. And this is the Orion Nebula. Look what's in between. It's like we're looking at like clouds in the sky. You see those? Look at that. Billowy clouds. These are dark dust clouds that actually are in this region of space, and they are part of this great Orion Molecular Cloud Complex, the OMCC. And the clouds themselves are far enough from the stars so that they're not actually scattering any of their light, but they are being illuminated just by the brightness of nearby stars. That's why it looks brownish. That's the actual color of this material. It's sort of a brownish, dark brownish color. You know? So this is really just an amazing photo. It's almost like a painting. And then we have these satellites buzzing through all this, right through the middle. It's hard to get a photo of the Orion Nebula now. But that's the way it is. But that's really pretty. There's the Running Man. Boy, that's just something else. That's really, really pretty. I'm hoping the wind calmed down and we're looking at a little desert cooling happening. See, here's another one. This is another one that I think is really cool. It's right here. Look at this brown cloud here. All it's doing, it's scattering a little light around its leading edge, but the rest of it is not, and it's just faintly illuminated by all the light from this nebula coming its way. That's crazy. Wow. Look at that. That's a gorgeous picture. Even with the satellite images, they're going to go. Let me get the right. Let me do a little color correction here. It's a little too green. There we go. Okay, now that is correct. What do you think of that, Darrell? Isn't that pretty?
Yes, it is.
I think I want to move a little more to the left, though.
Go for it.
All right, but to do that, I have to shut this down. But that's okay, because I'm going to go longer. So I'm going to clear this, believe it or not, and go back to 1 second for a minute. And with the 1 second, that's enough. I can do this. And then we're going to move to the east a little bit. So I want you to see the other dust in this region. Well, not that far east, man. Come on. Yeah, it looks like an eagle. You're absolutely right, Flames of War. And by the way, hi, Flames of War. Good to see you, man. Thank you, Izabela. By the way, Izabela Melamed that you see here, she is also putting up all of our table of contents in every single stream we do. I mean, that's a lot of work. So I want to thank her again publicly for all of that. You know, that's an awful lot of work. Thank you very much, Izabela. She's an artist in her own right, and if you want, you can put up your link, please, to your site. Feel free to do that. I can't do it from. I'm doing 20 things at once. Okay, let me. Let's go back to. I'm going to bring this up a little bit too. Okay, a little more. Oh, is that too much? Let's find out. Yeah, that might be too much. Let's check it out. Oh, that's a little tiny bit south of work. Let me just go to 16x motion right there. And now I can drop it down a little bit. There we go. I said down, I meant up. I'll move the telescope up a little bit. There we go. That cloud I wanted to get at is here. And because it looks like we're not getting a lot of the wind right now. Thank you, Izabela. Now I was thinking I was gonna have to close down, but I'm thinking maybe I don't. This is exciting. Okay. Oh, that again. Just they said that. All right. Let's give it a try. Okay, we're going to go up and do a 24-second shot of this region. It's going to do all this. All right, and we'll get rid of this. Okay. And I live stack it. And there we go. So as soon as it comes in, the color data will be probably incorrect, and the processing will be incorrect. Yeah, so let's fix that.
Is that the same satellites or more satellites?
It's just more. More satellites. Oh, yeah, that's just not going to happen. It's not going to change. It's going to be there for a long time, years to come. All right. Well, look at the clouds by the Running Man. Look at that. That's beautiful. You know, this is going to be a problem, especially for astronomers that want to study T-Tauri stars. Those are stars that are progenitors of another star. They're like young stars. And they're going to be really hard to view if we've got satellites running through Orion the whole time. If you notice, the time out there is it's 10 o'clock out there. You know, and you know we shouldn't be seeing satellites, but how come we do? It's because they're in orbits that are high enough so that the sunlight is still hitting them in some fashion. All we can do is allow or try to get the satellite trails to dissolve into the background from stacking. That's okay. All right, let's push this a little. Let's check out those clouds. You see how those brown clouds came in as soon as I did that? Here we go. Let's come out. There's that brown cloud I was telling you about, and then there's more out here. See that? This is this molecular cloud. Now you can see that this is a region within a very large, previously dark nebula that became illuminated because of those stars in the trapezium, which have lost forever in this saturated spot in the middle here. But you've got to overexpose in order to see this faint stuff. Very cool. Very neat, very neat. This is 7 stacked frames right now. Let's go to 100% of frame just to see what we've got now in terms of noise. The noise gets mitigated over time. So you can see it's not so bad. Alright. This is pretty good. Except for the satellite trails. Okay. Look at these streaks. All this detail and convolution. If you're on a, let's say there was a solar system, a star system around this star right here. You'd have to be in a very particular position to not feel the effects of the high ultraviolet light coming from nearby stars. But let's say somehow you're protected from it. You might not even notice this dust around you. You might not see this at all. Because once you get this close to it, it just sort of blends in. You know, it's like we're always looking out through dust in our solar system, the primordial dust from our formation. Certain times of the year we see it. It's called zodiacal light. We've actually captured it at the observatory and shown you with our all-sky cam, which we have. And the all-sky camera will often show us the whole view, 180 degrees and all around. And that zodiacal light is the remnant of the light pollution from our original solar system formation. All the dust left over in the plane of the ecliptic where the planets all move in. So it's actually, this is interstellar pollution, interstellar light pollution, I guess you might call it, which is kind of cool. This is a little blob right here. Where is it? Right here. There's a little blob right there. That might be a gravitationally condensing object right now. Right there. Very interesting. Well, I got to give the telescope credit and the stacking system. It's actually doing okay for the wind we're getting out there. The stars are a little bloated, but they're not oblong, they're round. Look at this. Look at this detail now. Isn't this incredible? you know, let's actually maximize this. But first, let's call it what it is. Let's label it M42 and the Running Man.
And M43.
Oh, that's true. Yep. All right. And so this is what it is. And let's just make it big because why not? So there we go.
Excuse me a moment, please.
Sure.
Izabela has a question. I'll stick around.
Okay. Okay. Okay, that's a good question, Izabela. Cyanobacteria, they're very resilient. And depending on the amount of radiation that strikes them, they may be able to survive it. They're not, they're not just going to die off at the slightest radiative energy. So it's possible that they could survive, but it takes a lot. They were the first colonists on our planet. Cyanobacteria, we also know them as blue-green algae. They are obviously, they require water to exist. And so if they are here, then it means that, or if they're there, that means that there's water there too, which means there's a planet that has an atmosphere that's thick enough to actually allow for liquid water on the surface. And in an irradiated environment like this here, it's possible that maybe they're shielded by some of the dark nebulae from the radiation, whatever. But hard to know. It's not an easy question. But that's a. Go ahead.
One of the early ideas for terraforming the planet Venus was to inject cyanobacteria into the atmosphere.
Yeah. And well, here it would work because our sun has ultraviolet radiation, but it's not the high amounts like in the trapezium. This trapezium, these young hot stars, 4 stars blasting out ultraviolet radiation for light years. I think it's like 24 light years across. I think, this Orion Nebula. It's actually pretty big. I'm astonished by these clouds. Look at this. I mean, it's like a painting. You notice the satellite trails are getting fainter and fainter. I kind of like that.
Okay,
Since we know what it is,
right
I'll
back.
just... Okay. I will cut this out of here for now. What do you think of this, guys? Is this beautiful or what? This is all live. This is live stuff, man. Ugh. I've just dreamed of this moment when I could actually just acquire the night sky like this. This is crazy. And in case anything happens, what I'm going to do is I'm going to just save this right now. Let it keep going. And save it again. Save it exactly as seen. Okay. And now it's saved. Okay, so now we've saved it, and it's going to go up to the server. But look at this. And you notice the adjustments I made to bring this over, to slide this level over to catch those clouds. It looked like it was too much at first, but then you notice how the image kind of ended up normalizing to it, and it became an okay amount. Well, I'm doing the same thing again. It's called pushing or stretching. So I'm stretching. This is called the histogram, that line you saw there. So this is about the limit that we'll be able to use. But we're used to seeing the Orion Nebula and then seeing the separate Running Man. Look at everything that's going on around it. This is a very, very complex location. There's an awful lot happening here. Okay, we're gonna go for a little bit of a. We're gonna go in at 100% now. All right, and let's go look up here. Actually, it's probably better to go out just a little. Let's go to 75. Look at that. Absolutely beautiful. You can actually see the light reflecting on the pillows of the cloud structure here. It is like a divine painting, Izabela. That's what she says. It's like literally like a divine painting. It really does look that way. You know? And no matter where we go in here, if we just come out of the nebula just a little bit, right? Just leave the nebula behind, then this looks like a tapestry of its own with color and splashes of color. You know, the artist dropped a blob of brown paint here by accident, right? It's like, you know, it's pretty impressive. It's incredible. You know, and then coming down, we've got all kinds of additional, whoa, yeah, okay, here I am, I'm back now. We have all kinds of additional features in here that are just so neat. And no matter how far you go, there's always more to see. Okay, and then down here. And then here. This is pretty right here. Wow. Alrighty. Okay, so we've done 30 of these, and I think that's good. Alright, we'll save this. I already saved it once, but I'm going to do it again. What's good about this is you can see that the extent of the reflection nebula, or that bluish nebula that we see, you can see that it's more than just the original structure of the nebula here. It's more than just here, right? Look, it's out here. It's in here. See the blue in here? It's behind here. You're looking through a little hole in this dark nebula to the reflection nebula back here. So you're looking at something like this, where, you know, this is where the dark dust is. There's a little hole, and through that hole you can see stuff in here, which is the actual, that little tiny blue object right there. That's actually through the hole. You know, it's sort of like Alice through the looking glass. This is probably one of the nicest photos that we've ever taken of the nebula. Notice the satellite trails are almost all but gone. I can actually remove them in finality and processing. But isn't that pretty? That's just beautiful as heck. Wow. Oh yeah. All right. So we'll pause this now. And I'll save it one more time. And I don't have to save the PNG because it looks almost identical. But that's another stack that'll be saved out there for you to check out. But the PNG, the ping file, looks just like this. It's out there now, waiting for you on the server. All right. And James Dugan makes a very valid point. James says, if only the trapezium wasn't so bright. It's a tricky image in M42, and M42, of course, is the Orion Nebula. And you're absolutely right, James. It's very tricky. For us to get the Orion Nebula properly, let's just clear this. We would actually have to take a photo that's around, let's see, let's pick 75 milliseconds. Okay, so for 75 milliseconds, all right, that's 3/4 of a second. All right, watch what we have to do. Okay, well, actually, we're on the live stack. I gotta remove that. Okay. All right. So now, 3/4 of a second, and let's bring up our values here. And you can see that it's still too much. See? So that's incredible. We can actually try it this way and bring this up to see just how much, because you can see the trapezium there. Actually, let's zoom in on that. It'd be a good way to see if we got our focus. All right. Yep, there's all 4 stars right there. That's the very center. That's that very bright set of stars in the middle. And we're at basically 3/4 of a second, you know. That's still giving us that. And then you can very, very quickly end up going and overexposing.
I said this the other night. I mean, that's what the dynamic range of the human eye will do for you. It'll let you see the trapezium and the nebulosity simultaneously.
Yep. Something we can't do with a camera without doing some magic tricks, basically.
Yeah.
All right, let's do this now. Let's move down just a little bit. All right. Well, before I do this, maybe there's something, because we've been going 2 hours 49 minutes. So we can look over here.
You want to try James's coordinates for the web now?
Yeah, I don't know if we'll see it, but we can try it. You want to give them to me?
Sure. Right ascension is 6 hours.
6. Yep.
59 minutes.
I'm putting that in right up here, guys. All right, let me get this out of the way. Okay, 6 hours, 59 minutes.
20 seconds.
Okay. And then that was the east-west coordinate. What's the up-down coordinate?
Declination is 5 degrees.
Okay.
31 minutes. 25 seconds.
Okay, so I just filled in the coordinates right here. And I'm going to say go to. And it's going to go to that. All right. And it's going to do a high precision slew, which means it's going to go to a nearby star first. That's bright. And then it's going to take that. And I'm actually at... I'm at 3/4 of a second. So this is at 1 second. See the difference? A lot more stars. Okay. Izabela, thank you. And that was so sweet. Okay, we're going to be amongst lots of stars here. So, somewhere around the middle of this field. Hold on, you said, okay, 659, 22, 530. Okay. Within this field, we have the Webb telescope. All right. But let's try something. Let's actually drop down this right here. Izabela, actually, again, that's so sweet of you. You do enough for us, Izabela. You really do. You know, with all the things you do for us. Incredible. Thank you so much. Now what I'll do is I'm going to make this a 55-second exposure. It's probably not nearly enough to show motion. What we need to do is take multiple exposures, time after time after time, like wait 10 minutes, wait an hour, take another picture, wait an hour, take a picture, and then we'll actually see the motion. I don't think this will do it, but we'll give it a try. Might be kind of cool to see. Okay, let's clear this. Of course, how's it feel to know that somewhere in that view we're looking at is our telescope 1 million miles away? Isn't that crazy? That's pretty cool. If the wind hits us, we're going to be all over the place on this image, but if not, it might be pretty good. And we saw with the Orion Nebula, we actually got a pretty good Orion Nebula, but it was a little more south.
I read some article about Webb the other day, and I don't know how to describe it. I hear some things, then I hear countering things, that some things they're saying just aren't true.
About what?
One of the ideas that was being put out was Webb at the L2 point is always going to be in Earth's shadow. And Webb will not be in Earth's shadow. Webb will never be in Earth's shadow.
No.
And the sun will always be in view from the Webb telescope. It has to be because Webb has solar panels. And if it was in Earth's shadow, you need to see the sun. So, you're getting power.
That's right.
And another one, I had heard both before, and they talked about this again the other day, wherever I saw this at. Webb does have active cooling. It's not all passive from the sun shield. It does have helium, I assume liquid helium on board for active cooling of the instruments themselves, I assume.
I think you are correct on that. I do believe you're correct.
And I haven't heard any more of what I sent to you about that Scott Manley video. Talking about two of the mirrors.
Oh, okay. Well, you know what? We're actually doing a stack right now. I just want to mention this. We're doing a stack right now on this. So, if the Webb is in this field of view, okay, we're going to see a little dash appear. But I don't think we're going to be giving it enough time. We have to spend close to probably an hour to capture it. But we'll give it a shot. Meanwhile, while it's doing that, while it's stacking in the background, there's a lot of stars to be looking at. We got nebulae in here. Look at that. Okay, we got all kinds of stuff in here. While it's doing that, why don't we actually take a look, and I'll bring up something to show you a little bit about one of the things I've been working on too. So let's take a look at my screen right now. This is the Webb telescope in a digital form. Okay, it's a digital model I'm working on for the Webb Space Telescope. So this kind of gives you an idea of what the Webb really looks like. Okay, this is an accurate model. All right, it's based on a NASA model, and these are the beryllium mirrors. Here, 18 of them. The instrumentation is back in this box back here, and this is the side the Earth is going to see at all times, and that's a solar panel right there. When it left Earth orbit, you saw the cylinder or the back end of it, and that solar panel deployed. That's what you saw. Now, because the solar energy striking this gigantic tennis court size diamond shaped thing has its own force to be reckoned with, this is on here. This is not a solar panel. This is what's called a momentum flap. It actually is also capturing the sunlight, and it is redirecting the energy of the sunlight and causing that sunlight to redirect in such a way that it negates the effect of the wind, the solar wind, striking the Webb telescope, which could move it over time. So you see, that's a very, very interesting design. They actually thought of those kinds of things, you know. So this is the reason I'm creating this, is because we're actually building a physical model of the Webb Space Telescope. So this here is a render that I'm making right now. You'll actually see a render of this right here that we're doing. Okay, so I haven't added all the textures to make it look exactly right. I did the brilliant mirrors. But, so this is what it looks like. You know? A very, very interesting telescope. No doubt about it. See that? And this, if you look at this bottom foil, it looks pinkish. It really is. It's a different material than the other upper 4 layers above it. So it's really kind of cool. And it's meant to actually absorb the most solar radiation when it strikes. That's why it's pink. So, all right. Anyway, there you go. That's a little on the Webb telescope that we just talked about. While we're actually trying to take a picture of it, it would, like I said, I don't really think we'll be able to get it. We'd have to really examine the photo in depth and carefully, but we will. This photo I'll save. You know. What Darrell says is true. They knew that they weren't working, but they have a potential workaround for it. I think they knew when they launched that it wasn't working, and they launched anyway.
Yes, that's what Scott Manley said.
Okay.
I mentioned that in a thread about the Webb over on Reddit, and boy, I took a lot of heat for that. People really got incensed.
What is with people? I mean,
they were, well, it's typical Reddit crowd, you know. That's the internet for you.
gosh, that just makes me crazy.
They started posting stuff, and NASA put up some stuff saying, "Oh, they're fine. We're just going to work on those 2 last, and they'll work differently than all the rest of the mirrors."
Okay, well, if that's true, that's good news.
Well, I mean, they really didn't say anything. Everything they posted, there were some statements on Twitter and stuff about it, and it frankly sounded like CYA to me.
Okay.
But we shall see. I mean, I've been keeping my fingers crossed, and I've already eaten crow for expressing doubts about the Webb in the past.
You have indeed.
It's been quite impressive so far. We shall see.
Yep.
I would like to
I'm
see
gonna
Scott
save
Manley
this.
follow up on that.
Yeah, it'd be nice. I'm going to save this anyway. So if anyone wants to go through and look for little tiny dashes, that will be fine. You'll be able to find it in here. It's going to be roughly near the center, but it could be a little below center, right? And that would be kind of cool. So I've saved them. They're up there now, and you can check them out. I want to thank James for giving us that website. That's very cool. That was awesome. Okay, back to a second, and let's go over here, and let's go to our program here. I'm gonna find, we're way up here right now. That's where he said to go. All right, but yeah, there's so many wonderful things to look for here. way back in the beginning, I forget, was it Michael Klages who said he wanted to see galaxies tonight?
I believe so, yes.
Well, let's find Michael a galaxy, shall we? Let's see what we got. There's a lot of very small galaxies in this area, but I want to see if we have any that might be of note.
Leo should be fairly high up in the east now.
I'm going to go look for that too, because he wanted to see the Leo triplet. And I would like to show him the Leo triplet if we can.
Mm.
Yeah. All right, let's see here. Okay, that's Aldebaran, some on that side. Bellatrix. Okay, let's move here.
Heck, do the
Sort
crab
of
while
near
you're
it.
in the neighborhood.
Yeah,
It's not a galaxy, though.
I know.
Galaxies are in the springtime sky, folks.
Yeah, pretty much. But you know what? We have
Yeah.
seen this happen. We have seen these before.
Yes, this is true. There are some
let's see.
small galaxies close to Orion, in fact.
I know there are. We actually looked at some.
Yeah.
But I don't. Oh, I think this is it over here.
Sombrero
Leo
is
is
not up.
Leo is still too low.
Yeah.
Here's Leo right here. You can see Leo the Lion right here.
Yeah.
Okay. It's a little too
M95
low
and
right now.
96 are under the belly, and
Under here.
M65 and 66 are under the hindquarters of the tail.
Down here. Then we have Coma Berenices. Yeah. These are just coming up now. So we need a couple more months to actually see those in the same kind of position that we see Orion in now. So I'm sorry about that. If you wanted, I know you were looking for something there, Michael. I don't even know if Michael's still here. But I think he's liked what we had to show him so far.
Yeah.
All right. So anyway, let's try something else.
Ursa Major? Will that be putting you up into the wind again?
Well, it's definitely going to be put me into the wind, but I want to see if maybe the wind is actually calmed down. I wouldn't mind trying it, you know?
Yeah.
Okay, hold on.
W13 Sombrero isn't up yet.
Yeah, it's not up yet.
Yeah, that's in Virgo, and that's even farther to the east than Leo is.
Right. Okay. 45 degrees in the northeast. That might be just doable. We can try it. Let's try it.
Sure.
All right. All right, here we go. You watch the telescope. It's going to lean way back and look out in the back direction here. Okay. It's actually probably going to get a little interference from the building wall. Maybe not. It looks like it's safe. And what are we going to be focusing on? What are we going to be bringing in here? Okay, Dubé. So we're bringing in Dubé. Right there. And
Yep.
so we're actually going to go a little north. We're actually going to be clear here to see it. Nice. And you'll watch them come in. There they are, right there. We have M81 and M82 Okay, we have the spiral galaxy M81 here, and the galaxy called M82 here, the classically called the exploding galaxy. And guess what? It's a starburst galaxy. It means a lot of stars are forming there.
They call it the cigar galaxy too.
They do. Okay, we have a galaxy here. I actually counted, I think 9 galaxies in one of the photos I took of this. Let's get our telescope now and just move it up a little bit. I mean,
still a 1 second exposure?
Yes. Not bad for 1 second. See, here's another one down here.
Yep.
All right, let's because this is so bright, I'm not going to do like 20 seconds. I'm going to do 5. All right. And it looks like the sky is pretty stable here. 5 seconds. All right. Here we go. Let's get rid of this guy. Get in the stack. Clear whatever we have to if we still have something in the stack. And we do. That's been saved. We're going to clear it. And now we'll see. There we go. Now check it out. And satellite. Just let's add satellites to the mix too. That's probably Starlink right there. Look at this galaxy. This is Messier 81 and this is Messier 82. Messier 82 has this neat burst of gas coming out of top and bottom. That's glowing in hydrogen alpha light. It's really red, which means I should probably take a longer exposure to show you that. But let me just let me zoom in. Let's go to 75%. We're not quite ready to look at that yet. I want to check the focus. The focus looks a little soft, so I'm gonna fix that first. Might be soft though because of a little breeze, but let's check it out. Let's get rid of the stack and let's just do a examination here of this. Okay, now that's perfect. That's a good star for us. Now we're gonna go to 100% here and then move up. And yeah. And we're going to focus with that star right there. And if our model is correct, we need to lower the number a little bit. 50.8. Yeah, we got to lower the number. So let's go down now here. Okay, that's getting better already. $48,011. I am getting some wind motion though. Alright, that looks pretty good. So we'll set there. 48,009, and now we'll now we're going to go back to temperature compensation and use that as a new set point. You swing the telescope around and things happen all the time. It makes changes in the temperatures. Okay, let's back out now. Stars are going to look like little pinpoints. They're going to be beautiful. Okay. And come on. Thank you. And now let's go back to this guy for a second. Yeah. Okay, now let's do this. Let's set this to 20 seconds because I want to show you the detail in here. All right. So there we go. 20 seconds. Pull up the stack. Clear the stack. Trust me, it only gets better. All right. The M81 galaxy at the bottom, that's the bottom center. That's also going to be overexposed a little bit with this exposure, I can tell you. Yeah, and another satellite. Wow. Oh, and we got wind in there too. See that? We got a little wind effect. All right, clear that. All right, so 20 seconds is too long. Let's go 13 seconds. All right, and by this time, this satellite will be gone. All right, let's clear it. All right. This guy here is already zeroed. This first one now. All right, let's do that. There we go. All right, so we've got one right here. We have one right here. All right, we have one here. Galaxy. You can see the red going up and down. This will get sharpened in. We have something right here. I'm not sure what that is. And of course we have M81 here. So as we do more of these, it's going to lose a lot of the noise. There's something right here that's a little bit green, and I'm not sure if that's possibly a planetary nebula or what. I have to check it out. Let's see. Yeah, a little elongation here from the wind, but just get an idea. I'll show you what this looks like. This is M81 galaxy. This is a beautiful spiral galaxy. Look at the knots of stellar nurseries inside this galaxy. We've got stellar nurseries in there. Those are like Orion, many of the like little Orion nebulas, and possibly even larger that we're seeing there. Those are just beautiful. Okay, and then if we slide upward and go to the other galaxy, you see nothing of the sort. You see, in fact, that you have this blast of stuff coming out of the center and going up and down. And it's a very, very bright galaxy, so it's easy to lose detail in here. Let me try. I'm going to increase the black point so it makes space more black. That's in turn going to change how the galaxy looks. So you can see a little better now how that looks, right? But it's not quite the same. Let me pull it down so you can see more detail as we play with this. That's what processing is all about. But pull this black point back a little. Expose a little more black point.
I've said before that I don't remember that red showing up much, frankly, if at all, on old film images of M82.
Oh, you're talking about this fan
yes,
stuff.
Yes.
Yeah.
And it really shows up on time exposures on digital images. I don't know if that's just the difference between film and microchips or what, but
oh, not at all, Izabela. I don't know, Darrell. That's a good possibility. Let me show you guys. Izabela, was this from our? From yes, it was. It was a previous one. Yeah, that's beautiful. Okay, let me show folks. This is Izabela's processing of Measure 81 and Measure 82. Okay, let's zoom in, shall we? Yes, we shall. So there you can see, this is what the images I'm showing you look like when you process them. And this is M81. Look at that. Isn't it beautiful?
It is.
Yeah. And she lost a little bit of the hydrogen 2 regions, the stellar nurseries in here. But that's okay. I felt that the telescope probably wasn't focused at its best. So she was going at it from a little bit of a crippled start. And if we come down and we go to the left, right, then we have this galaxy here. Very pretty, Izabela. Very beautiful.
Can we zoom in on M82 there?
Yeah.
No, that really shows up.
You can see it very clearly.
Oh, well done, Izabela.
Yeah, that's gorgeous. What this shows you, and this is what I was trying to say before too, is all that data is actually in these files. It's just that you don't see it all, right? So here is our M82, right? And here is Izabela's M82, you know? So it's actually, if I put it there, and I go back, I bet you it's going to be almost lined up. Almost, kind of. You know? That's pretty cool. I'm getting close. Just gotta go like here. All right, now let's see. Watch. There we go. Look at that. So that's what we're shooting right now. Okay, that's what we're stacking right now. And her processed image looked like this. So you see, there's this really cool detail in there. Well done, Izabela. As always, well done.
Wait till springtime, Izabela. You're going to have your hands full.
You will. There's a lot of galaxies to process.
Yep. Springtime is galaxy time.
Oh, yeah.
Of the 1,000 brightest galaxies in the sky, 3/4 of them run in a band from Ursa Major down toward Coma Berenices and Leo and Virgo.
Yeah. Right.
And it's just full of galaxies in the springtime.
Mm-hmm. So I hope you guys like this. This is kind of cool, isn't it? I would say so. So once again, let me remind you of our full field view. This is our full field view right here. And we can actually zoom into, you know, really quite a detailed view, because this, again, this camera is the actual field of view would take up way more than just a screen. And as you can see, this is the full size view. This is the native resolution of this camera right now. And there's so much more on either side, in the top and bottom. So that's what's really cool. These red dots you see here, you'll see blue ones, you'll see green ones. Those are what I call angry pixels on the camera. And we process those away. It looks nice, though. The wind is not affecting us here. This is good. Look at this dark. You see all this dark material in this galaxy? This is pretty good. You know, M81 is showing nicely tonight, Darrell. This is going to be a good processor.
Mm.
You got these beautiful, the bluer disk showing these hot blue stars that have formed out in the spiral arms. Really pretty. We've actually stacked 35 of these, so I think we're pretty well done. So we'll pause this and save it. You gotta save it. And no, it doesn't save with the zoom. It saves the entire frame. So you see the whole frame. And then save exactly as seen. What it's really saving is a view that's It's going to be this size right here. Okay, it's going to be the full frame. So you don't have to worry. All right, so there's a live stack of that. That's saved. We're going to clear this. And now, I'm wondering if we can do a little Thor action. I don't know. Maybe we can, maybe not. You know what I mean?
I am Thor.
Right. All right. Here's what we're going to do. I'm going to go and do a search for it. Roar. Roar.
Right down near Sirius. Probably getting close to the meridian now. Or Sirius is anyway.
That's my hope. So let's find out. Yeah, we look like we're at a good altitude, and we're almost level with our red box will be perfectly level. See, when we're directly in the south. See.
Yeah.
So that's a little past. So we're very close to the meridian. So
Sirius,
we're gonna go. Yeah, it's probably gonna use
Emerson?
Sirius as a guide. So watch overhead now, guys. You're gonna watch the telescope now. It's gonna head toward Thor's helmet, one of Izabela's favorites. So there we go, and it's probably gonna go to Sirius, but we'll find out, and we'll know right away. Here it comes. Okay, we're getting there. It's going to stop right about now. There it is. Yeah, that's Sirius. You can't miss it. The brightest star in the northern hemisphere. Brightest star in the sky. Yeah. All right, it's going to center it up, and it's going to bring us. So it's blinding light.
8 light years away.
Yep. Yeah. I think it's like 7.9. I don't know.
Sirius is a famous double star also.
That's
I
right.
have never seen the B component of the star.
The Dogon think they have.
It's actually a white dwarf, and it's so faint right next to the bright Sirius A that people have a hard time separating the two. They really shouldn't be hard to do, though. It's just the difference of brightness that makes them so hard.
Yep. Let's. Oh. Well, Darrell just accidentally hung up on us, so I'm going to call him back. So, pardon the interruption. 1 second.
Hello?
Are you over that? Are you over that now?
I guess. What happened?
I don't know. You hung up.
I didn't hang up.
I didn't.
It just disconnected. I thought maybe there was a problem or something. Well, try to share your...
Yeah, I guess I should share so you can see what we're talking about. Boy, did you miss it. It was the coolest thing.
What's that?
Nothing. That's just a joke.
Oh. I was sitting there prattling about Sirius. I don't know if you heard any of it.
Yeah, we did. You talked about Sirius, and I was talking about heading to Thor's hammer, Thor's helmet. I'm just looking at the focus here, and I guess it looks okay. Yeah.
Well, welcome back, Darrell. Hello again, everybody. I don't know what happened. Skype just dropped out.
Okay.
Terminated.
Well, hey, it's Skype. You have been terminated. It's the Terminator. It's what I do. All right. Izabela, Topaz denoise is very nice. I use it in my pipeline, my workflow pipeline within Photoshop. And the best one is for removing the stars. That one, the one for removing the stars, is StarNet. That one is really beautiful. StarNet removes the stars very nicely. Darrell hates it, and I understand. You want to see stars. I got you. I get it. But when you're trying to process images, it's really best to separate the nebulae from the stars, because if you sharpen stars, they look terrible. Yes, StarNet's the best ever. It's an AI plugin which allows you to remove the stars from an image and then process only the nebula. Okay. Let's move this a little bit.
Excuse me.
Sure. We're going to center this up like that. Okay, and then we wait the obligatory 11 to 12 seconds for the guide star acquisition. But meanwhile, I'll be putting in the timing here. I'm going to do 45 seconds, and let's hope that the wind is not going to affect it, because if you look where it's looking, I think we're going to be okay. And we'll get out of our hybrid mode and go into our live stack and clear this. Yeah, and now.
Did you save it?
Oh, of course. I did. That's a good question, weird guy. Izabela, does StarNet have settings to allow you to keep the stars? Is that what you found out? Is that what you figured out? Wow, look at this. That's beautiful. It's coming out well. Let's drop this down a little. Wow.
Izabela
Impressive.
asks an interesting question. I know different Wolf-Rayet stars, they have a preponderance of different elements in their signatures depending on the type of star.
Yes, but the different Wolf-Rayet stars also do different things. Some blow off their helium envelope, like the bubble. Some blow off different parts of their envelope, like Thor's helmet. So there's hydrogen in Thor's helmet, but there's also oxygen. And Thor's helmet, depending on the type of star, there's many different kinds of WR stars, as she says, or Wolf-Rayet stars. 50,000 Kelvin, very, very hot stars heading towards supernova. They're a very special breed of star. And depending on what they produce in their cores, they can blow off chunks of their envelope, and those chunks can be made of different things, and you'll see them differently.
Yeah.
Let's zoom in here. See, this is a perfect object to remove the stars from. Well, see, Thor's helmet is interesting. See, the star right here you're looking at, that right there, that star, that is the Wolf-Rayet star. That's the very high, powerful star that's blowing this big bubble and all this material here. This is gas that was in the envelope of the star. But the star has blown a lot of that off, and you're seeing the hot interior, the hot core area left behind. The star did not go supernova. That's still yet to come.
Yeah.
So these stars are in a strange evolutionary phase of their existence.
And I assume the different Oh, what you see there is like wings or something. If not the different arms and such or wings, but the gas at different distances from the central star must have departed at different times.
Yes, but you also have to keep in mind that some of that gas could have overtaken the slower moving stuff. So that
Right.
big bubble, for instance. Now, I'm not saying this is how it happened with Thor's helmet because I don't know the chronology of events for Thor's helmet, but it could have blown that bubble first, and that bubble was a large mass expanding slowly. But then this stuff here could have been blasted off of the star at very, very high speed and went past this material. Maybe this bubble was complete before. If we notice now, it's not. It's missing a whole side. Maybe this stuff is what that used to be made of that side. Maybe it just blew through it
Yeah.
and took it with it. We don't know. So that's what's interesting about that. The wings look like the star is rotating. Well, that's another thing too, Izabela. Wolf-Rayet stars have different rotation rates too, obviously, and I think that that's part of the issue. Is trying to figure out which Wolf-Rayet star, which WR star you're actually looking at. So I think that's pretty cool. Wow, it's 1 a.m. Okay, we've got 6 stacked right here. We're gonna keep going. I want to get a lot of these. It looks like the weather is cooperating. It looks like our focus is cooperating. I'm just going to go to 100%, make sure.
Yeah, I'm going to have to call it a night here in a little bit.
All right. This is a very complex nebula. What I'm going to do now is I'm actually going to try and push a little detail out of this.
Wiki says Thor's helmet is very similar in nature to the Bubble Nebula, but interactions with the nearby large molecular cloud are thought to have contributed to the more complex shape and the curved bow shock structure of Thor's helmet.
Yeah. And that's always the case too with a bubble the same way. I mean, the bubble has it has like an asymmetric expansion because usually you would expect it to just go spherically out, right? Because a star is the same everywhere on all sides. Except when they get into like super giant size, sometimes they have large blisters on their outsides of giant locations that cause flares. It's a slowly undulating mass that looks anything but a star. It's roundish, okay? But here, what we're looking at is the dark molecular cloud. You can see some of it here, okay? And what happens is, as the material flows out at high speed, it hits this material. This is dark dust. Well, that dust has mass, and it slows the stuff down, which in turn can heat it up, both the gas and the dust. Yet it's already being heated to very, very high temperatures by this star right here. Okay, this star, if you notice, has sort of a blue tinge to it. Wolf-Rayet star is very hot. They're going to be blue, very hot and blue. So this is just a marvelous example of a location. This, I can see that we're still having some noise from the wind, unfortunately. But that's all right. It's okay.
Yeah. Several hundred solar masses of ionized material, plus several thousand more of unionized gas. It is largely interstellar material swept up by winds from the central star, although some material does appear to be enriched with the products of fusion and is likely to come directly from the star. The expansion rate of different portions of the nebula varies from 10 kilometers per second to at least 30 kilometers per second, leading to age estimates of 78,500 to 236,000 years. some parts of the nebula are moving much faster than other parts.
Yeah.
It is unclear whether it was produced at the Class O main sequence stage of development as a red supergiant, a luminous blue variable, or mainly as a Wolf-Rayet star. It's great big, it's real hot, and it's going to blow up.
I hope a supernova.
Deja vu here. I'm having a, yeah. I've read this before. Go ahead and say what you were saying.
I was gonna say that I really hope that we get to see a supernova nearby, like one of these stars and so forth. That would be really pretty. This is actually, we're up to like 12 stacked, and look at the detail now. This is starting to look really nice. See that?
Yeah.
It's becoming more complex.
Yeah. And there are at least 5 wings sticking off of it.
Yeah.
I would be happier seeing Thor's helmet blow up than I would Betelgeuse, I think.
Oh, you're just going from an aesthetic point of view.
Yeah, well, this is 12,000 light years away.
Yeah, Betelgeuse is 750. We'll get a ringside seat with no danger.
Yeah.
Man, I'd love to see that. I would love to watch the shockwave expanding, the light echo basically expanding out from Betelgeuse as it goes off. At 750 light years, we'd be right there to see it. And the nice thing is, that's the kind of star that when it goes, you would actually notice it going from another galaxy, just like we do.
Oh, yeah.
So this would actually be a very, very beautiful object to see explode. Betelgeuse we're talking about. From within our galaxy, from the ringside seat we have. We're in the part of the galaxy that's been classically called the Orion Spur. What that means is we happen to be in the part of the galaxy where Orion is sort of a little hidey hole in one of the spiral arms. And that's why all the stars of Orion are so bright, because we're very close to them relatively. We're like 1,500 light years from them, 900 light years, 750 light years. So we have a closeness to the Orion Nebula. Look at that dark nebula in here. It's really getting very pronounced.
Can you zoom in a little more now?
Yeah, maybe I can. Actually, I'll do it this way.
Structure in that shell is really interesting.
It is. Actually, it's really odd. That's neat.
As you said, it's sort of like it blown out the shell on the left side.
Yeah, it's missing a shell.
Yeah.
So I think the interactions with the interstellar medium probably stunted the expansion of the shell of this direction, I would think. Mm-hmm. We can't see all the stuff that's in here, and again, it's in 3D, so we don't really know exactly which way we're looking at it.
Yeah, but still, there are places there. There's that dark bar down at about 6 o'clock. It's like the lower edge of that. Yes, that right there. There's a big one over at about 9:30. Out toward the end of that other leg there. No, farther up. Farther
this
up.
One I was talking about.
To the left. Right there.
Oh, here.
Yeah.
Yep.
That's rather reminiscent of that cloud you were looking at. That dark arm you saw next to the Orion Nebula.
Yeah,
but I'm sure that's much bigger. And
I got
The
this whole
wing up,
thing right here.
yeah. The wing up at the top has got a similar dark bar right there.
Yeah. Yeah.
I think
the more I look at this, it's not just that simple shape anymore. There's just a lot more to this. It almost looks like a splat more than, I mean, these are the typical wings that people see. They see this, they see this, they see that, and this. And they say, that's Thor's helmet. No, actually, Thor's helmet is all this too up here, see?
Uh-huh.
So much to it.
And I can see where I think those dark bars along the edges of those wings are. Izabela shared an image she did recently of
Yeah.
processing Thor's helmet, and it showed as really red. And I suspect those dark bar things are what was red in her image.
I can see this has more of a dusty brown look.
Yeah.
And this is ionized oxygen that we're seeing here. And as is the case with Wolf-Rayet stars, you know, you don't always see hydrogen. Sometimes there's no hydrogen.
Right.
And that's the case here. We see the oxygen, right, but we don't see the hydrogen. So.
Well, as you said, different Wolf-Rayet stars sort of predominate in different elements.
Yes, and Wolf-Rayet stars are very complicated. You actually, if you understand Wolf-Rayet stars, that's probably all you understand. You know, you don't dig into. They're a science all their own.
Yeah.
And it takes a lot of time to just wade through all the different types of Wolf-Rayet stars you've got. If you're doing research, I'm sure that you can get tied up for many years doing research on Wolf-Rayets. So, I mean, it's just phenomenal. Okay, we're at 20 stacked here. I'll go up another and then we'll stop that.
Well, that's quite a picture.
And actually, it looks pretty good. And we're at 100% of the sensor, too. So that's not bad. It's the best one so far we've taken. Won't be the last. I promise you. Okay, we're going to pause this right now. Save it. Okay, the FITS file's on its way. And the ping file, exactly as we see it here, on its way. Now, just to give you an idea, okay, let's now go back out to our full frame to show the full frame. Look how small it is. It's among these many stars, though. Makes it almost hard to see. That's why we remove the stars, so you can see it better. Alright. Well, that's cool. That one's nice. Alright. Let's clear this right now. Get rid of the stack. And I know you have to, you want to make a beeline for your sleep, so I'm not going to make you stick around here.
Okay. Yeah, I'm going to call it a night, I think.
Okay.
I've been trying to go to bed a little earlier at night.
All right.
All righty. Well, folks, it's been great, and thank you all for coming, and thank you for having me, Mark.
Absolutely. It was wonderful.
If you carry on...
I think we'll do two more objects. I think we'll do the Seagull Nebula, and then I can't help it. I have to do the Rosette. So we'll try the Seagull Nebula first. All right. And then go to the Rosette. But, Darrell, it's been a pleasure having you. You're always welcome, obviously.
Very good. Well, thank you. Again, thank you for having me. Everybody, take care and have a good night. I hope you had a good time. And I wish you all a good night. I'm going to go to bed. Okay, y'all take care. Thanks, Mark. Have a good night.
Good night, brother. We'll see you later. Well, there we go, folks. And now It's just us. What do we do? I know. We'll look at some cool things. Okay, we're centering Sirius. And now we're going to the Seagull Nebula. This is a rather extensive nebula, as you can see. And it's actually going to be pretty cool. You're going to like this one, if we can do it without wind affecting us. So, step one, let me zoom way in and check our wind status and our focus status. Focus looks okay, but I'm gonna try something. Okay, 49.4, and temperature's down to 47.99. Okay, let's just drop it down a little bit. Just doing some focus stuff here. Okay. Yeah, see the wind? See how it's moving it? Moving a little bit. It feels weird not having someone on the air with me. That's okay. Alright, this looks good. So let's go turn this back on and let it make adjustments now, as it will. All right. All right. Now we back out. Jessica. I don't think you want William Shatner because he is the epitome of overacting. I mean, don't you think? That's funny. Now look how that's really pretty now. This is going to be pretty. Okay, we're going to slide eastward on this one a little bit. Hey there, Bonnie. Anahata 77 is here. I did not see you here earlier. I can't imagine you just got here. I think you've been here, but you've been kind of lurking in the background. Am I right? We're going to bring the telescope down a little bit. You're going to like this one, guys. This is really pretty. It's just a beautiful, extensive nebula. When I say extensive, I mean it's huge, as you'll see. Jinx. Huh, that's funny, Donald. See what Donald wrote about Larry Niven's novel? Yeah, you gotta love the chat, right? Okay, let's see what's going on here. Okay. Now... Okay. Vera, what did you lose? Vera says, apparently I've lost that virtue. What'd you lose? Okay, let's, wait a second. It's still going off the bottom. I want to bring that up more. Okay, we'll do this. It's gonna be off the top and the bottom, no matter how I slice it. All right, so let's do a. We'll do 28 seconds for this. Okay, Izabela, don't worry, they will fill in. Oh, Vera, you're funny. Not a problem. Okay, here we go. I noticed the other night that images were coming down slowly to the server. Alright, now let's go in here. And we got everything set. So, check this out when it comes in. You're going to like this. Very complex region. Let's see if we can get a good view of it like this first. Okay, let me do a little bit of a processing and color balance. Wham! Look at that. Is that not beautiful? Wow. Wow. Check this out. This is the Seagull Nebula, guys. There it is. That's the seagull's head, obviously. These are wings. How beautiful. You see, this is why I love astronomy. Because hiding up there among the stars, you have beautiful sights like this. Just incredible. It's okay, Bonnie. I'm glad you're here, though. You can be quiet if you like. The Seagull Nebula, yes, Izabela. Guys, make sure you have it on 1080p, by the way, your stream settings. So you actually see it the way it should be seen. Let's look at the head a little bit here. Wow, now that's pretty. Focus looks good. Dark nebula with just a little bit of reflection nebula there, that special nebula we talked about. Jackie Jacks, what's happening? Good to see you. By the way, I hope you guys, those of you that are here that haven't subscribed, please subscribe. Love having you. This is the Seagull Nebula. Yeah, let's bring it to the full screen, shall we? Poof. There we go. That looks really pretty. We can actually bring it down a bit. It's so neat, you know. You come to here and you don't know what to expect. Next thing you know, you're seeing live imagery from deep space. And this showcase is spectacular. It's just sitting here. Hi, Laura. Laura Newbert's here. Nice to see you. And these objects that we're seeing here, these nebulae, they're thousands of light years away. So you're seeing them as they were thousands of years ago. And for the most part, they're probably not that different now, but they do have differences that they go through. There's different phases of evolution that nebulas go through too, because as they make hot young stars, those hot young stars are gravitationally interacting, they whip away from each other, and then their capability to cause this dust and gas to be either reflecting or ionized goes with it. And so a cloud like this that you see as a hydrogen gas cloud, like this right here, right, this cloud with this ionized hydrogen that glows such a beautiful red, it's glowing a beautiful red for now, but the time will come when the stars that are causing it to glow will have migrated away, leaving the cloud of dust and gas once again in the dark, and it will go into obscurity once again. And that's kind of the romance of the universe, you know. Very cool, very cool. Just a second here, adjust that. There we go. It's like I'm dancing. Hey. There we are. Okay. So we have stacked 12 here. 12 of these, and it looks pretty good. We can see these little subtle areas right in here, which I think look really nice. You know? Okay. This right now we're at 100% of the frame. This is the native frame size for our image, for our camera rather, that we're using. So we have a really good size frame, and you can see this beautiful, very complex seagull head, if you will. That's the eye. It looks like the beak is turned backwards a little bit, and that's the beak right there. So if you look at it that way, I guess the seagull is sort of looking back this way. Top of the head, back of the neck, eyeball, and beak. I guess if you think of it that way, right? Yeah. Gorgeous. Absolutely gorgeous. Okay, we did 15 frames here. We're good with that. I'll pause it right here. I'm going to save it. And then I will save it exactly as you see it. Okay. So that'll go up to the server as well. By the way, if they don't show up on the server for some reason, maybe there's a connection failure somewhere along the line, they're actually all on this machine here in the observatory. So we're not missing anything. We'll never lose anything. It's being saved right now on that machine, and it's just going to get shipped up to the proper location. Let's go back so I can watch the telescope in operation here. There's a telescope over my head right there. Okay, let's go down to our 1 second control here. Right here. 1 second. Alright, and then we'll see the little remnants of the seagull now right there. Okay, now I want to take us to one more object that's just a favorite, and tonight, the way it looks, I am quite certain it's going to be just beautiful tonight. There's so many things to see around here. It's incredible. I think you guys are familiar with this, but each night it looks a little different depending on the quality of the night. And tonight is an exceptional night if it's not for the wind. So we're going to try to look for this particular object. It's going to be pretty high in our sky. And let's hope the wind doesn't destroy our attempt, as it has for some of the other things we did. Okay, we are centering Alzir, which is the star here. You can't tell because we're at 40%, not auto. So now when you do this, you'll notice it's better. So it's Alzir. And then after we do Alzir, we end up going to this beautiful, beautiful nebula. A nebula beyond compare, called the Rosette. And you can see tons of detail in it now. And it just looks beautiful. I'm going to try something a little different tonight. And I'm going to see, first of all, if the nebula it's almost overhead, so it's going to be the most beautiful we've ever seen it if I can capture it without the wind killing us. Don't worry, we have other nights if this doesn't work. Alright, so alright. Okay. Let's jump into 100% on this and see if we've got any wind issues. That's what I like to see. A locked image. No wind. Good focus. Oh, we're golden. Well, I hope you guys enjoy this object. Alright. Get ready. This is the object that's the quintessential beauty. You think the Orion Nebula is beautiful? Wait till you see this one if you haven't. And we're going to make this a 35-second shot. Oh, yes. You see our green bar over there moving. That's telling us that the photo is underway. We can even count. If you can read that, you can see that we are at 22, 23, and going up to 35 seconds. I hope you're ready for this, because it's really pretty. And a satellite. Well, yeah. Ay. I just picked the wrong time, didn't I? It's gonna be going here. Yep. Well, in any case, this is the Rosette Nebula, and it's gorgeous. Let's zoom in a little. Oh, Raymond, thank you, man. Look at this. It is beautiful. Wow. Thank you very much. Yep. 35-second shot, Rosie, Raymond says. Yeah. See, this is what's beautiful about this is it has all these beautiful details in it that we capture most times. You know, we've stacked 3. Okay, I could get the same amount of data by just taking I don't have to take a 35-second photo. I could take a 30-second photo, and this thing, I can let this thing leave. I've got one more image and it's going to be gone, and I can just start over again. Raymond is great. You know, I gotta say this, Raymond, from the bottom of my heart. You know, I think if you are getting as much out of this as I think you are, you make it worth it. You really do. You really do. obviously I love what I do. If I didn't, this wouldn't be happening with it. You know, our GoFundMe supporters are just phenomenal to get a lot of it done. So we're still underway. Okay. I'm going to do the unthinkable, and I'm going to clear this and start over. That's okay. It doesn't take that long. Oh, but you know what? I do want to change this to 30 seconds. We don't need to do the extra 5 seconds. There we go. Starting over. Yeah, that's what that is now. Alright, so we'll clear this. So the next one, it's going to be out there. So that's fine. It won't be in our object. You know, it's funny, you know. The Rosette is not... It's bright, but it's not very bright to take photos of, depending on where you live. And out there, you can almost see it with your eye. Wow, there we go. We have a clean Rosette now. Wow. Let me see if a color correction can help to color the nebula a little bit. I know I can do this a little bit. Okay, the Rosette is a beautiful stellar nursery, star-forming region. Go away. And what's interesting about the Rosette is this void in the middle, this cavity. This cluster is the reason why the Rosette glows. Okay, this young cluster, a few million years old, has what it's done is it's actually ionized a lot of the hydrogen gas in this cloud and caused it to glow through that method we talked about before. But these stars have also created a cavity around themselves, which is what you're seeing here. That's why it looks like a donut. That's a big spherical cavity inside this nebula. And this spherical cavity, carved out by these stars, has been swept clear of a lot of the dust and a lot of the gas that's in there. And it pushes it out. And as it pushes it out, it leaves sort of a void in there. All right. Now, if some of these stars are extremely hot, if they go supernova, then they're going to blast their stuff out into space. But that'll happen, you know, in a few million years if they're hot stars. If they're not, then they may last a billion years, maybe more. If they're O stars, they're going to last a very short time. B stars, longer time than A, F, G, K, M. We're a G star. We last about 10 billion years. Wow. All right, we're up to 5 already. Now that's really pretty. Let me see if I can just push a little on this. Get a little brighter. And pull back the black level just a tad. I'll come in here now. Yeah, Laura Newbert, it is a beauty. Laura says, oh, what a beauty. It is. It has a lot of depth to it, Raymond. You're right. You know. Let's go on a little cosmic journey here. Let's go take a ride into the middle of it. So here we go. So now you see the interior, what's going on in here. Look at these dark tentacles, basically, of dark dust. And these beautiful things, almost in 3D. These gorgeous locations. Something else to notice, too. Up here, see that little lonely black thing right there? Another one right here. It has a little shiny spot above it. It has a little tiny spot of illumination. Those are called Bach globules. I've talked about them before. Bach globules are gravitationally condensing globs of dust and gas that may eventually form stars or a star and potentially planets. All right. Really pretty. Oh yeah. God, this is really pretty. See? This is why I love astronomy, yeah? Like that. Look at that. That's the reason. Right there. You can't beat this. You can't beat that. It's really just beautiful. Yep. Really beautiful. Oh yeah. So this whole region has dust in it. Yeah. Yeah, Bach globules, Izabela, yeah. Yeah, tendrils, yeah. I call them tendrils before, but they reminded me, and you look at, they look like squid tentacles. Okay. Actually, this is a squid tentacle that I actually grew on my 3D printer, and it's actually my iPhone holder. So it's a sort of a squid tentacle, and it kind of reminds me of the Rosette Nebula. Oh, I'm sorry, Raymond, yeah. But you know what? This type of thing right here, Raymond, and as Bonnie says, it makes her heart sing. You know what? It makes so many hearts sing. You know, including my own. So I know for a fact that it's through the rigorous application of astronomy and science that we're going to eventually leave this planet and go to other stars. And if you look at this image, there's so much for us to see out there. You gonna come along? I bet you will. I want to zoom in right there. There's something there that I think you'd like to see. It's a little tendril of gas, a little spike. Okay, what we call a stalk. It is so deep and complex, you know. But you zoom in and you see this stalk right here. See a stalk right there. See a stalk right here. Part of one there. What are these stalks? What they are is at the end of each of these stalks is an area that's gravitationally condensing, getting dense. And then the stellar winds from these stars, you notice it's on a radius, it's on a straight line away. Okay, the reason is that these stars are blasting this area with radiation, and it's pushing the dust and gas away. But the areas that have high concentrations and that are gravitationally condensing, okay, like as I was just saying, like this spot right here, okay, the gas is blowing down this way, but it can't get around this very dense object. So this stuff right after, behind it, right there, is preserved. Right? Same thing right here. Okay, the stars are blowing on this, but it's actually condensing, and these are that wind can't affect what's directly behind the glob in that line of sight. And that's what we talk about when we talk about stars that are using the radiation pressure to create these stalks in space. And again, at the end of those stalks All right, we see that on the end of these stalks, there's these densities, and these little densities of objects will eventually possibly become stars or stars and planets. So we're literally watching. We are watching the universe build itself right before our eyes. It just happens very slowly, you know. So, gosh, this is pretty. And we're at 18 stacked images here. And the wind has not been a problem for us. It's one of the nicest photos of the Rosette I've ever taken with this telescope. Very complicated. And the thing is, it's happening live right before your eyes. That's the thing that I just still can't get through my head. It's happening live, and it's 2,500 miles away from me that it's happening. So I'm really just astonished with how beautiful the universe is. Look at that. Look at this right here. I mean, we're way zoomed in. You can see details within this tendril. 2 young stars right there. Probably red because of the dust that they're embedded in. So it's really kind of cool. Wow. Well, we're at 21 stacked. That's good for this. I hope you guys have enjoyed this. Because I have. I really enjoyed your company tonight. You guys are wonderful. Very lively chat. I really enjoyed your questions. I'm always available for answering questions too. So that does it for tonight's stream. I'm gonna be heading out, and Izabela, we're going now anyway. So we will be back on the next clear night. We're trying to go every other day, so we'll see what happens tomorrow. If it's clear, you know what? You know me, I can't help it. I gotta do it. So we'll see. We'll see. We'll see. Time will tell. Anyway, you folks have a good night. This file is up there. It's heading up there to that server. So you enjoy. Oh, Raymond, thank you, man. That's just amazing. Oh, thanks, Raymond. That means a lot, actually. Thank you, man. That's very kind words. You know. All right. Well, folks, thank you very much for coming tonight. And, well, remember, actually, when you go outside, keep looking up, okay? Because what's up there is hiding from you. And all you need is a telescope and someone who's crazy enough to stay up all night and show you this stuff. And here I am. So you guys have a good time and have a good evening, and we'll see you next time. All right? So good night, guys.